our GTA forum. So first in agenda will be opening statement from the Secretariat of the CBD. Right now, our director, Mr. Alexander Shostakov, is approaching. Yes, please kindly open the GTA forum.
Thank you, Marikha. Good morning. So, I think that for some of you, or maybe for many of you, it's not already the first day of this conference, although conference didn't start officially yet. So, but I'm happy to welcome you to Sharm El-Sheikh, to COP14 and this event, which is happening in an important time when entire biodiversity community and of course all parties to the convention are jumping into a 2-year journey towards new biodiversity framework. So as Junko said, my name is Alexander Shostakov and I'm director of the division with a new and exciting title of our division now, Science, Society and Sustainable Futures. So this division of the convention brings together all major elements of programs of the convention, both thematic programs but also many cross-cutting issues. And global taxonomy initiative and taxonomy work within convention is one of those cross-cutting issues with its own program of work, which going for a number of years within the convention, as many of you know very well. And GTI as a program of work was established within the convention with a view to remove taxonomic impediments which exist in implementation of all 3 pillars of convention. So whether we are talking about conservation of biodiversity, or we are talking about sustainable use of biodiversity, or we are talking about genetic resources and benefits we can receive and share coming from the use of these genetic resources. I will refrain from actually talking how and why taxonomy is important for convention, but also for advancing our work on biodiversity. I don't need to talk about it in this audience. You know it much better than I do. I'm actually, my background is a physical geography, landscape sciences. So I don't know that much about taxonomy and rely very much on your expertise here and of course of my colleague Junko, who is running fantastically this work for a number of years in the Secretariat. What I'd like to say for the next day of your work here, what will be definitely important is that you have an exchange of practices and newest approaches within taxonomy. I think that since taxonomy initiative was established under CBD, with the development of current technologies, the taxonomy is in a very different place now than it was at the time of GTI was established. All new technologies, all new approaches, which developed very often in developed part of the world, but that's also need to be a part of what's known within the convention as technology transfer and cooperation. They need to be shared, they need to be transmitted to other parts of the world. And we also know, yesterday we had a breakfast of like-minded megadiverse countries. And we know that substantial part of biodiversity is actually staying in those countries, where the capacity and knowledge and scientific expertise can be not necessarily that highly developed as in countries where probably biodiversity is not that much rich. So the issue how we translate the knowledge existing in other parts of the world to those parts of the world where we really need to focus on biodiversity is an issue. And I was also happy to see all those posters which definitely reflect your work, and Junko, your work in organizing this very important initiative on capacity building in different parts of the world for taxonomy, but also bringing taxonomy to decision-making process. That's also important. Science is fantastic, science is great, but we need to know how to use science, and scientists also need to be aware of what are the needs of decision makers, policy makers, but also what are the needs of people, and how you can translate your fantastic scientific knowledge into something tangible and useful, whether it's actually at the customs, checking what's coming in or out of the country, or it's an agricultural sector, or it's actually even for ordinary citizens to understand better what is around them. So I'd like to thank all institutions, but also all individual experts who participated during last years in this initiative, who supported this exchange, who supported getting new data, who supported the transfer of knowledge and technology to other parts of the world, but also to other colleagues. And of course, the process also to get new trainers who can do their work nationally and even at the local level is extremely important. So again, thanks to all of you who participated in this process. And maybe the last point, as I mentioned already, and as all of you know, we are in the process to come to the new framework, which is a post-2020 framework, which we believe will be one of the key milestones towards achieving the biodiversity vision of 2050, where we all supposed to live in harmony with nature. What does it mean? And how we come there? And how the new framework will look like. COP14 on the 29th of November will adopt a decision on the process toward development of this framework. And I hope very much that during this day, in your deliberations, also in smaller groups, you may actually discuss how you like to see taxonomy in the next 10 years. What will be the role of taxonomy in supporting new set of targets? What will be the role and needs of taxonomy in this new framework? And how it can support framework, and where is the place of taxonomy in this framework. So that definitely will be useful for all our work, and our discussions they will start actually right after COP14, having the mandate to run the process for the new framework. While actually the focus is very much on the new framework, I definitely also like to remind everyone that we still have 2 years until 2020. And that's why all focus not need to be only on the new targets. Maybe first of all, still priority within those 2 years is to do as much as possible for achieving Aichi targets and bring our countries and our world and our societies as close to achieving those targets as possible. So please don't forget, whatever you planned until 2020, that's still a priority. So do not need to be like shadowed by this exciting new strategic exercise for post-2020. So I will stop here. I wish you a very fruitful and nice meeting, exchange of information, ideas, data, and elaborating on new ideas, which definitely as a Secretariat we will be very much welcoming. You know, our internal capacity is limited, so we have, of course, fantastic Junko alone. So without your support, without your help, your engagement, we can't achieve a lot. So please help. And we definitely are here also to help you where we can. Thank you very much and have a great day.
Thank you very much, Sasha. We would like to have a few minutes for question time because Sasha has to leave for bureau meeting, and if anyone of you wanted to know more about the process and the Secretariat's business, how we will make things forward, any questions or suggestions, you're very welcome to raise.
at this point of time. So, but we are always available during next days. And again, whatever you will produce for this day, we are very much looking forward to see results. Thank you.
Thank you very much. So now that GTR Forum is opened, and next will be a keynote speech. I don't have to introduce Dr. Carlos Manuel Rodriguez, Minister of Environment and Energy in Costa Rica. Just briefly, of course, Costa Rica is a champion of the taxonomic knowledge use for the national capacity development and national implementation of the CEPA. He was starting his career as an environmental lawyer. In his previous life, he was a head of protected areas, senior vice president for Conservation International, and 3 times Minister of the Environment. And Carlos, you have a floor, and the Global Taxonomy Initiative is welcoming you very much so.
Thank you. Good morning. Thank you, Junko. Alex just mentioned that his background is not properly suitable for giving a scientific speech. I'm in a less suitable position because I'm an environmental lawyer, and a lawyer at the end of all. But let me tell you a small story about my professional career and how I link this to research in taxonomy. When I was leaving high school in 1977, I was going to the university, and I didn't know what to study. I was very much into studying biology, but I come from a family of lawyers. So I decided to study biology and law at the same time at the University of Costa Rica, and that was like hell to me. On one side, I got, chemistry and statistics and mathematics, and I was struggling. On the other side, on the law, a lot of law philosophy and principles of law, I hated. And I was doing very bad in both careers. I was failing. So I had this conversation with my father. My father is a 4th-generation lawyer. And I asked him, I'm struggling in both careers. I need to decide which one I should pursue. So he said, very wise words from my father. He said, okay, if you study biology, the more I see you will be probably the head of the zoo in Costa Rica. You'll be the head of the zoo. If you study law, I know you like nature and farms and coffee and all those things. Law gives you a general knowledge that will help you engage in the future, many different things. You don't like law, you got a general knowledge where you can, do whatever you want in the future. So I meditated and followed my father's advice. I studied law, and then I did my master's and PhD and other things. And now I'm the boss of the head of the zoo in Costa Rica. So in 1983, when I was working on my thesis at the law school, I decided to do a legal analysis on the wildlife law in Costa Rica in 1983. The wildlife law in Costa Rica was basically only conceptualized mammal or vertebrates. And that same year, when I was doing my research, I read a book that really opened the eyes to me. It was the Natural History of Costa Rica, written by Daniel Jansen. And I said, oh my goodness, we got a law that tries to protect wildlife in Costa Rica. And by then, we didn't have the concept of biodiversity. We only talk about wildlife. And I said, if vertebrates are just 7% of Costa Rican biodiversity, we got a national law that only protects 7% of our biodiversity. I mean, it was like an opening of a dimension to me. And I said, I need to contribute in enhancing Costa Rica's laws so we can be able to cover legally the protection and the wise use of all forms of life. So out of my thesis of 1983, we work out in what we eventually called the wildlife law, 1992. In that law, we cover all vertebrates, minor flora. We never had a law that protected minor flora. We had a law that protected or has an objective on trees, but because of logging purposes. So in the wildlife law, we include trees, all kinds of plants. So if you add all vertebrates and plants, that is 20% of Costa Rica's biodiversity. So we did progress, but we didn't cover everything. We wanted a law that not only protects, but help us to understand what we have there based on this concept of the three principles. The first principle is protect all you can as fast as you can of your natural heritage. And we've been doing that through the National Park Service and public conservation and private conservation. As you protect a good representation of all the natural biomes in the country, you need to understand and learn what you have protected. And yes, Costa Rica had probably 150 years, a lot of research being done on these, on these species which are easy to work with, which are basically vertebrates and plants. So, and the third element of our conservation strategy, as you protect the sites, as you begin to understand and map what you have there, you need to use that knowledge in the sake of human needs. How do we go from, toxic chemicals into organic solutions or natural solutions in the agricultural sector in many different sectors? So in 1992, we approved the wildlife law, but once more, vertebrates and plants is just 20% of Costa Rica's biodiversity. Immediately as we approved the 1992 wildlife law, we began to think, what is the next step? And at that same time, we were already, Costa Ricans were, myself, I was a very young guy, 32-year old, working on the Rio Summit, and working on the UNCTAD process that later helped us to generate an agreement, and we have this convention, the CBD convention. So as we work in this international process of drafting this CBD convention, we continue thinking, how do we create a legal framework that really covers all of Costa Rica's biodiversity? And in 1998, we approved the biodiversity law. Costa Rica was the first country that had a biodiversity law. For the first time, we fully incorporated invertebrates and microorganisms. Not only cover them in terms of the need to protect them, but also in the need to use that resources and that knowledge associated to the resource in a sustainable way, which in a way is fully implementing this, the three principles of the convention. As a matter of fact, that biodiversity law was, I would say, a visionary law, because later on, many of the things that we established in 1997, 98 in Costa Rica, and the biodiversity law was what we later on approved in this convention. It is now known as the Nagoya Protocol in 2010, which is, access and benefit sharing. And that was great, because we had to deal with many issues in terms of rights, and there were not much international references associated to rights. Who owns biodiversity, and who owns who has the rights to own and use the genetic and biochemical resources? So I was part of that whole process, and through that whole process, I support in many different times and was fully engaged in many different moments the effort that Costa Rica was doing in mapping all kinds of biodiversity. We created the National Institute of Biodiversity. We worked a lot with a group of leaders local and international research and scientists in Guanacaste Conservation Area, which has been our kind of most science-based conservation area where we've been mapping, and we did it, same way we have done, research and taxonomy. We go to the field, we systematically gather information, then we bring it to the experts, and we spend years and years trying to classify. But the approach was very interesting. How do we mix the national inventories process with the need to really understand the benefits of using those resources? I was one of the first lawyers that worked on bioprospecting with the Institute of Biodiversity in 1991. I was helping the Institute of Biodiversity do the first bioprospecting international formal agreement with Merck, Sharp, and Dunn, and then with many other international biotechnology companies and research institutes, universities that work in Costa Rica. It was an endless process of learning and knowledge, and that was great. But throughout the 90s and early 2000s, while we were doing all of these inventories, even we participate, Costa Rica, in this old taxa inventory, which was a very interesting approach. We wanted to do the old taxa inventory of life and this planet. Very challenging. But a thing happened that really changed the view of everybody. Two things really happened. One, internet came. We didn't have internet before as a tool to use it to do our inventories and to do our field work. And then DNA barcoding came up. These two things really changed the panorama. Even though I'm a lawyer and a frustrated biologist, because I never went from year one in biology school, I've been working with wildlife and researchers all my life. And I remember 15 years ago when we were working on the Mesoamerican biological corridors and working with charismatic species like the jaguar, we thought that we had 4 subspecies of jaguars in the neotropics, and that we need to protect them. And then the DNA, technology came up, and we thought 4 species because they look very different in 4 places of the neotropics. The Belize jaguar is 100 pounds, the Pantanal jaguar is 200 pounds. Those are 2 subspecies without any doubts. And then DNA came, and boom, they told us, it's just one species. One species. So, as a politician, as a lawyer, instead of trying to understand some of those things, my first question when I found that result was, if there is just one species of jaguar, that means that there hasn't been an isolated population anywhere. So there's a corridor somewhere. Let's find the jaguar corridor. We're talking about 17 countries. There's a functional corridor that is, is the highway for genes to go up and down, north and south, east and west. So we dramatically, with that DNA information, we dramatically changed the approach on jaguar conservation because our idea was to create a corridor. DNA information told us that there was already a corridor there. So our task, instead of creating a corridor, became, how do we find that corridor? And we know where the corridor nowadays are. And we're working on many different aspects. So the internet and the DNA barcoding is going to be a revolution. It's a revolution. And in that context, and based on all of this background on the Costa Rican experience, Costa Rica, with the BioAlpha initiatives, wants to become the first bio-literate country in the world. And this is fabulous. This is fabulous because what we have done in Costa Rica for the last many years is really compelling. I remember as a minister, like a month ago, I was in Tortuguero National Park and I was visiting the nearby community, and of course, as a minister, and I need to go to school. Costa Rica is probably the country with the highest investment in education per capita in the world. So we ministers, no matter from what sector we are, we always put a lot of effort on our education, on our educational system. So I went to this small school in this remote area where there are 20 kids from different grades, from first grade to 5th grade, and just one teacher. One teacher school in a remote wilderness area in Costa Rica. And yes, I had a very nice conversation with the kids, and I began asking them, I asked the kids, I want you to name me the national parks, 10 national parks of Costa Rica. And all of them did the 10 names. And one of the smallest kids says, Costa Rica bears 4% of the global biodiversity, and gave me a speech on biodiversity. These are kids, very poor kids from remote wilderness areas. Costa Rica already has done a great investment in bioliteracy, and we want to do it big time because of technologies and opportunities. So it's not just a matter of ethical responsibility and be able to really complement the way we prepare the future Costa Ricans. Working in a project like BioAlpha will give us a lot of information that we don't have today. If you ask me, the Minister of Environment of Costa Rica, how is Costa Rica doing in protecting biodiversity? I kind of choke myself because I don't have an answer. I'm not the Minister of Finance, which I can easily, using my data, can tell you the health of our economy. I'm the Minister of Environment, and I cannot tell you the health of my natural capital. And I challenge every single environmental minister who's attending this meeting, probably 60 to 80 ministers, if any of them can give an X-ray of the state of life in his country. Nobody can do that. Nobody can do that. So it is extremely important that we generate information where we can support decisions. How come, I compare myself with the Minister of Finance. He has all data for taking decisions. I, as the Minister of Environment, I don't have the data to take decisions. And I don't have a baseline data where citizens can assess my work and my job. I cannot be able to step and look to the eyes of the Costa Rican and tell them how I'm doing in terms of accountability. Do we have more jaguars than 20 years ago? Well, I would say yes, because I go all around the place, but do we got more freshwater fish and invertebrates in freshwater environments? I don't think so, but I don't have the data. I mean, what is happening, I don't know. And if we don't know what is happening, we're going to lose a lot of things. So it is important not just from the ethical perspective of preparing the Costa Rican, but using the data and the information for a better, more smart decision making. How do we assess the impacts of climate change? Yes, we know that ants are going beyond the 2,000 meters mark, and that is, something. But what are the main indicators that we should use to assess climate change? How do we use this knowledge of doing the inventory in terms of shifting the way we produce our food, the systems, how we produce our food? The way we produce our food is probably the most threatening activity to life in planet and biodiversity. And the work that we have is tremendous, because we need to change dramatically the chip on how we produce our food. And let me give you an example. If you are an organic producer, you need to certify that your food is produced organically. But if you produce your food with poison, nobody obliges you to label that your food has been produced with poison, hazardous to your health. But the good guy who wants to do different and do the right thing, he's obliged to certify his products. That's the level of challenge. We need to change dramatically everything. And I think that until we really understand not only the impacts on life on planet based on how we produce our food, but using the knowledge of that biological diversity can help us not only in terms of food security, but in being able to feed all humans in the future. So thank you for the invitation. I encourage you to keep on doing this. We are a small group of scientists in this big convention that many times doesn't realize how important is the work that we do. I'm a scientist, not a biologist. I'm a politician, and I work on political science. I need the scientific information to do my work. You know, I need to bring the information that is being generated by field biologists, by researchers, so I can be able to impact major decision making at the country level. So I'm really pleased to be here. Wish you the best for these next days, and encourage you to keep on doing this. A final comment. You know, by 2020, we need to come up with this new framework and a new kind of approaches. And I say, yeah, but we need more than that. We need to take bold political decisions. Let me give you an example of political decisions that I, as a minister, will be pushing. It's not just increasing protected areas and doing this and the other, very much similar to what we did with the Aichi target. Now is the time to take urgent, bold political decisions. What are some of them? In my personal view, eradicate wildlife trade at the global level. All countries in the world should ban international wildlife trade on endangered species. Another bold decision, let's make deforestation, land use change illegal everywhere in the world. In Costa Rica, it was declared illegal in 1996, and things changed dramatically. Let's stop logging primary forests. It's the dumbest things we can ever do. Let's begin phasing out the use, systematically phasing out the use of fossil fuels. And a good one, why don't we do the global all taxa inventory as a direct commitment of this convention in the next 10 years. Thank you. Have a good day.
Thank you, Mr. Rodriguez, and highlighting about old taxa inventory. That is a big dream of taxonomists indeed, and also it was one of the time-bound actions of GTI capacity building strategy. If you have any questions, I would take one question from the floor or comments. Okay, thank you very much. Then I would like to move to the next agenda item. That will be Costa Rica's another best practice moving on, the old taxa inventory with the full participation of citizens. And that is an international collaboration. I would like to invite Professor Daniel Johnson. He is participating remotely via internet. His talk would be on BioAlpha, a new project to assess impact of is it connected?
Dan, can you hear us?
Okay. Are we on?
Yes.
Okay, Dan, I think you would be better person to explain about the BioAlpha. We apologize for the...
Can you go ahead, Dan, with your presentation?
Can you go ahead with your presentation?
So Dan has been in Costa Rica working with all those para-taxonomists and citizens.
Yes, you are.
Yep. Yes, he's on.
Yes.
Can they hear me?
Yes.
All right. Good morning, good morning, good morning. As you can see from this first slide, this is our goal, and this is what Costa Rica is all about. And you just heard a very nice explanation of that from the Minister of the Environment. Now, as you can see here, the goal in the narrower sense is to biodevelop Costa Rica for itself and for the world. And it's meant to be a model bioliterate country for non-damaging use of its whole wildlife, and that means all of them. The title for the project is BioAlpha, which means bioliterate, or comes from the word bioliterate in Spanish, as you can see at the bottom. Costa Rican biodiversity is at COP14 today because we're trying to biodevelop the biodiversity of the country. Carlos Manuel is here on behalf of 5 million Costa Ricans and 1 million, at least, wild species. Costa Rica will become the first tropical country to actually know its wild biodiversity. What it is, where it is, what does it do, how to find it, get it on the public internet, and therefore become known to everybody. Costa Rica is a very small place, as you can see at the bottom of the map here. Moved on the United States, it's tiny. But in biodiversity, Costa Rica is 4% of the world, and North America is 4% of the world. In other words, Costa Rica has a very large package of raw material with which to work. These are shareholders, and I mean it very literally. They're the people who really matter in this game. Of course, we matter as well, but there's 1 million of them, and this is a shareholder interview. Now, what you see down here is a snake being held by a 5th grader, a farm kid, and these are other 5th grade farm kids around him, all part of a very large education program centered on bioliteracy for everybody, 4th, 5th, and 6th grade. But what I see in this photograph is 1, 2, 3, 4 iPhones taking a photograph. And at that moment, 40 or 50 or 100 other kids are also seeing that snake. That is the world we're in today. Now, we've been doing this as a pilot project up here in northwestern Costa Rica for 33 years. It proves that what I'm talking about today is possible on a countrywide level. At this point, we've already done 450,000 barcodes for 45,000 individual species of things. And I have to thank BOLD in Canada, the government of Canada, the country of Costa Rica, and JICA from Japan for having allowed this to be possible. This is a DNA barcode. Think of it as a unique identifier for that fly up there, expressed as one word with 650 letters in it and an alphabet of 4. This is taxonomic infrastructure and gives us a unique species identifier that's machine readable and can be gotten by anyone. At the end of the day, each specimen ends up with a record, photographs, UV, specimens on a pin, as you might expect, but also a DNA barcode, as well as a genome extract in a freezer, which can be under contract done things with as well. This also exposes a whole lot of stuff we didn't know was there. There are 10 species of butterflies in this box. All of them have been masquerading under one name for more than 100 years. A very common butterfly in Costa Rica that everybody sees in their gardens. The specimens that come from this are being collected by ordinary people out there on the countryside. These are called parataxonomists, and they do more than just collect and prepare the specimens. They also write articles about them. And if I click on this particular header right here, we get text, we get photographs, we get knowledge by one of those people who had before never written a sentence in his life. And this is him 30 years before. A professional fish killer taken out of that role and put into a very different role of understanding what is the biodiversity of his own country.
Dan, sorry, Dan, I must stop you here. We have a problem. Now it's okay. Thank you.
Okay, that's good. With only one of them with a higher university degree. All the rest maybe made it through 6th grade. These are the people who would be out on the countryside doing all the countryside jobs regularly, taken out of the countryside and taught how to do what we expect of a good graduate student. They're called parataxonomists. At the other end of the scale, in Canada, is this group of people at the University of Guelph who are doing the processing, the genetic processing of those specimens. And this photograph is full of PhDs and master's degree students. Is that right? What we're building towards is a global GPS for biodiversity. So instead of coordinates, it gives you a unique identifier for that organism. And where it's headed is we can all have it in our own pockets. Today, with a field, with a laptop, thanks to Nanopore, you can do $45 worth for one insect in the field. In the lab, that same insect is $3. And in a very short time, it'll be 1 penny. In other words, in a very short time, we will have 8 billion people on the planet able to have in their back pockets what that comb costs. And that comb can be the barcode reader, and that gives them the unique identifier, which allows them to know what humanity knows about the thing that's in their hand or their mouth or just about anywhere. Costa Rica is 1 million species of wild crops, as you just heard from Carlos Manuel. But high biodiversity really isn't a brand. There are other countries with a lot more, okay? What Costa Rica has as its brand is it's biodeveloping that wild biodiversity. And in order to do that, it has to know what it is, where it is, what it does. This book, which you'll recognize as Biodiversity, Biodevelopment of Birds, has brought more good in dollars to the Costa Rican economy than any other book ever published. And this is in the paper days, before internet. Now, what's the raw material? The blue area is insects, and the other colors up here are all the other things. So what it really says is that the blue area is the area of a huge amount of raw material not yet developed. So we have all these insects, let's put them to work. The one way to put them to work is with a thing called a malaise trap. Think of a tent with a door open, and insects fly into it, end up in this bottle up here, which goes into that bottle down there, and you got, after a week of this, a bunch of insects in alcohol. They're all, nearly all, undescribed, hundreds of species, all mixed together. The only way we can know what those things are is to take them out one at a time and DNA barcode them. Later on, we'll be able to barcode the whole mess as a whole, but first you have to have a barcode library against which to compare it. So in effect, this trap is doing the same thing that a rain station does, because the rain station collects drops of water. The trap collects individual insects, and then we analyze the outcome from those two things. So now how do we actually do something with that? This is the ACG, the conservation area, where all this is taking place, and right over here, I can't see it, but there should be a yellow star over here. And with that yellow star, the government very much wants to do a major geothermal project. This is the ACG here, a World Heritage Site. This is outside of it over here, and the forest is the same. The boundary runs between the two. So the question becomes, if you go in here and do a geothermal site, what is the effect on this forest? That's the resource underneath all of this. A huge amount of potential electricity for Costa Rica. So let's look closely at that site. That's the drilling site, and the trap is right under this yellow star. The electric company has been at war with the Park Service for decades in Costa Rica. We went to them and said, would you allow us to treat your industrial site as though it was a scientific experiment? And we will figure out and see and we'll record what actually your site is actually doing to the forest. They said, okay. So we went out and put those malaise traps at the edge of where the site was going to be, 50 meters into the forest and 150 meters into the forest in 3 places. And what happened? See, here's the beginning. This is where they just cut a big chunk out of the forest. There's the malaise trap from day 1. Developing site, there it still is. Now it's doing in the industry for 3 months, is drilling to get the hot water that comes out, the steam, the hot water that comes out of this underneath. And we have a trap right here running all the time. What comes out of that? 144,000 insects collected during 1 year from 7 traps. Those had 11,000 species of insects in it. This was all DNA barcoded by Guelph in 6 months. And everyone with a unique identifier. 91% success in that huge sample. And I'd like to thank both JICA and the government of Costa Rica and the narrower, the ACG, and the mother institution of the ACG for the opportunity and the funding to carry this out. It worked out to $3.14 for each insect to get a unique identifier attached to it. And now we have a track through the whole year for how each of those traps behave. And they all behave the same, except for one. And that's the one red one that you can see right here. Now, where is that trap? That trap is right on the margin. But 50 meters into the forest and 150 meters into the forest, there's no sign that this platform exists. So the damage done is the 2 hectares of the platform, not spread out through the forest. Where we are now is to analyze the 2nd year to see if it is spreading or whether it's staying contained where the forest is. This is using insects as a biomonitor. And you look at this and you think, ugly hole in the forest. No, in fact, that's a landslide. And when we have landslides in national parks, nobody objects whatsoever. And then you say, no, but the landslide is going to close over, but the geothermal site is not going to close over. Unfortunately, actually, the landslide is permanent when you have a river. Because there's an edge, there's the forest, and there's the piece that never closes. All right? So all of a sudden, the National Electric Company finds itself working very closely with the park system. And this is their slide, created by the industrial people, showing that they are moving towards the park people to work with them. And look right here, the grease for that, the gasoline for that, came from JICA in Japan. But it has other side products besides biomonitoring. This is a very nasty little fly that bites people. That's my hand. And you kill it, and you can see the blood coming out of it from the damage done, called Samelium. We go on the web, and lo and behold, we get the name directly off the web by comparing its barcode with Mexican specimens, who were also barcoded and given a formal scientific name to Mexico. Fine. So now we know who the little flies are that are doing this. You go on the web, and you look up and ask, this fly that bites people, what does it do? And the web tells you it only eats people. So we suddenly realize, oh, we can barcode the gut contents of that fly and find out what it really was eating. And what you discover is it was eating all of these species of other vertebrates. Birds, bats, mice, big vertebrates, small vertebrates, not just human beings. Those are all potential disease vectors. In Costa Rica, this little beetle called La Broca is a major pest of coffee, which is a major, major crop for Costa Rica. Major problem. It's been known for more than 100 years. We catch them in the malaise traps, we barcode them, and we discover that where this red line lies, there are 11 species of this pest, not just one. This is getting everybody to work together. The idea is these are all the government agencies over here, all of them contributing sweat equity to bring this thing about. Joined with the taxosphere, the classical taxonomists and the museums and taxonomic knowledge, Crowdsourced, citizen-sourced, nation-sourced, and the commercial sector, the private people, and the NGOs all working together for one effect. Costa Rica's on board with that already. Ask the Park Service, where is there electricity in the parks? That's the yellow dots. They give you a map right away. Here they are. Ecotourism lodges can have a Malay strap sitting outside of them. The parks also obviously can have one. These are the high schools in Costa Rica. Canada put 100 Malay straps in schools across Canada and caught more species of insects than were known for Canada in 1 year. People are being paid environmental service payments. To tell us what kind of biodiversity. The country as a whole is suffering from climate change just like every other tropical country is. This is 1985. They're very much reduced, not at all, in many, many days. This is a good day on the top of that volcano. This is Death Valley on the top of that volcano. How can we monitor that? Normally you use thermometers. We can use insects for the same purpose. This is all part of a global program, not just Costa Rica sitting down here with 3 Malay straps in it right there. These straps are all over the world, and all this information is being proved together in bold in the University of Guelph and available to everybody. All of this is public domain. What does it cost to make a country bioliterate? Well, Costa Rica is a little place, and it only has a million species. But it's going to cost about $100 million spread over 10 years. Half of that money is to do the mechanics of doing the barcoding and getting the specimens and organizing all the information and getting it on the web. 25 million is to stimulate biodevelopment with that information, and 25 million is to endow the whole process so it continues to roll forward. That has to come basically from some cash source, hopefully from a friendly government. The country puts in an enormous amount of sweat equity. Now we suddenly have 5 million people all willing and part of the system. Now, what do these things have in common? Every one of those. They have one thing in common. There's something there for everybody. If we get a unique identifier on every one of Costa Rica's million species, there will be something there for everybody. The GTI has 4 major goals: enhanced use of existing tools, capacity development, decision-making, and sustainable taxonomic research, all melded together. That's what this project is. This is my last slide. Many of you saw this when you were in grade school. This is the Wright brothers airplane. And what did they do? They showed you could fly 300 meters without killing yourself. Somebody else, other countries, other people developed the aviation industry. They did not do that. They showed that you could do it. Costa Rica is trying to be the Wright brothers airplane for the tropical world. Thank you.
Thank you, Dan. And any questions? Dan, it was very convincing messages all over your work done with Costa Rica and DNA barcoding. Thank you very much. Any questions once again? No? All right, so thank you. The coffee is ready, so we will move the coffee break a little bit up towards the end. Oh, do you have any questions? Yes, please.
Yes, thank you. It's just a short announce because Costa Rica will have a side event tomorrow at 1:15, and we are going to give more details about what is barcoding working, and we are going to share with you more detail about our experience. So all of you are invited. Thank you very much.
Thank you. So everyone who is interested in on this work, please join that side event. And now we would like to move to coffee break, and then it will be followed by a talk on museums, collections, and bioinformatics. So let's have a coffee break now for 15 minutes, and then we will be convening everyone at 11:45. Thank you.
To the Consortium of European Taxonomic Facilities, which is a collaborative project. And this is dangerous, people. This consortium is a grouping, is an initiative by basically the large European natural history museums. So at the moment, this is a consortium of 59 institutions in 21 countries in Europe. Together, we manage 1.5 billion specimens, which represent about a little bit more than 80% of all described biodiversity. Within the institutes, there are over 100 collaborative projects in which over 2,000 scientists are involved. Our institutes welcome more than 6,000 scientific visitors per year. We publish more than 3,000 scientific publications a year. We have 10 million public visitors a year. And we have in our website over 25 million web visits a year. So we're quite big, if I dare say. And what we are doing is that, well, we work on collections-based research, and mostly in three major groupings of our activities. One is earth sciences. Much of what we are doing is to do with geology, and I hope you forgive me that I won't go into details on geology today. This is not really about geology, as I understood. We're mostly working on life sciences, animals, plants, fungi, microorganisms, and anything that does not really fit into those groups. And of course, we are historical collections. So much of what we do have is in our libraries. We have all these old documents, old publications, which are extremely useful and even necessary if you really want to do taxonomic research. So I hope you agree with me that, well, this is quite impressive, isn't it? Now, what we are doing is we are doing taxonomic research. Now, I do hope that I do not have to go into detail what taxonomy is for this audience. I suppose that most of you present in a GTI, Global Taxonomy Initiative side event, you would know what taxonomy is about. It's a science. It's a basic science, fundamental importance for understanding biodiversity and ecosystem function. It deals with exploring and describing biodiversity, starting at species level and classifying things into phylogenies. It allows us to report, track, and understand evolution. So we are really working on bringing this all together in taxonomy, and much of taxonomy is based on the examination of specimens. And these specimens are based in collections. Now, these collections are, of course, extremely important for us because that's what we are. We are taxonomic facilities working on collections. So these taxonomic facilities, as I said, we manage, and, which is even more important, we give access to research and education on some 1.5 billion specimens covering more than 80% of the world's known biodiversity. These collections allow us to do science being based on reproducibility, of course. So for that, we need to be able to re-examine these specimens. We have to give access to the specimens that have been examined before to see whether our conclusions are valid. We need this for information on their occurrence and their associated biological, geographical, and ecological data. Now, these collections are the repositories for the study of evolution of organisms and to their genetic variation in time and space. So these collections are the pillars for explaining evolution of life on our Earth. And we do this as a consortium to achieve common goals. Now, these common goals are more or less fourfold. First and foremost, we realize that our institutions together, they form the largest taxonomy and systematics network in Europe. In fact, we are the largest natural history science communication platform in Europe. We, as a scientific research infrastructure together, we form the largest natural history collections infrastructure in Europe. And we also offer the largest training and education facility in Europe for taxonomy and systematics. And by bringing this all of us together, by grouping, we can be more than the sum of the parts. By pooling our resources, by pooling our influence, we can have a collective impact which is much larger than we can reach by simply working one next to the other. By working in a collective way, we reach a critical mass in European natural science institutions, which together brings us at the level of the large research infrastructures in Europe, which are so well known, like these major things in physics. Together, by working within our own member state in Europe, with our own governments, together we can have an influence on the European level, which is much larger than if we were to work on our own member state level alone. And by working together, we can benefit from opportunities, mostly funding opportunities, of course. So not only by having more influence, but we also pool our resources. By pooling resources, we increase the efficiency of whatever we do. We share our resources, skills and expertise, and our knowledge. And together, we can also offer better services to society. So also by working together, we can harmonize our approaches and our provision of services. And then, I'll give you a few examples of what we have been able to do in the past. A few examples only, is that we have established in a European project, the Distributed European School of Taxonomy, which for the last program, we were able to offer about 130 persons different training programs held in 16 institutions in 10 countries, which is quite significant. Together, we built the Open Access European Journal of Taxonomy, which is fairly peculiar as a journal. Neither the contributor or the user have to publish. It's open access and free for all. And it is quite high quality. It answers to all the scientific standards. We are contributing by digitizing our historical library resources to the Biodiversity Heritage Library. So making all these old publications available through the internet for all. Moreover, we are also doing some other things like developing and offering Scratchpad, which is a bioinformatics tool that enables taxonomists to collaborate over the internet. We are working together in BioCase, which is an access service to our collections. And these are all projects which we have been working on in the past. I will go back to the future later. So this is really set up as a unique community created by our district's members. And how does it work? Well, there are some underlying ways of doing this. We have different bodies to enable this collaboration, to facilitate this collaboration. The first is, we have a number of working commissions focusing on particular issues. Second is, we have so-called subcommittees, advisory groups or panels for certain specific uses. And third, we have special interest groups. Now, I'm not going to go into details of all of these. It would take me a bit too long. Allow me to give you a few examples of the first, which I think are relevant to the particular case of this talk, is the training and e-learning group. The second is the legislation and regulations group. And the third I'm going to briefly mention is the strategy group. Now, first and foremost, training and e-learning, which is, of course, about capacity building, which is extremely important, as we've just heard from David Hansen. There we discuss things, well, how are we going to organize this capacity building? How are we going to assess and improve and create and develop e-learning activities, which are extremely important? How are we going to bring these together? There are all sorts of e-learning activities going on at different CETA member institutions. How are we going to assess them and improve them? We are going to think about developing joint training in e-learning and taxonomy. And of course, very important, trying to find the resources to organize all these things. And we're going to keep on doing this by developing more joint training initiatives involving our members. We are going to establish a European taxonomy training program, or at least we are going to hope to establish that. And we're going to continue searching for funding. But as you all know, resources is always and ever a problem. A second one, which I would briefly like to introduce to you, is the legislation and regulation group. There we have a group of people working on trying to make sense on access and benefit sharing, which, well, we are citizens of parties and we have to follow the laws of our countries. We have to follow the international laws and local laws and also the laws of the countries in which we work. And that for us is extremely important. For if we want to be sustainable, we have to follow the laws. So here we have a group focusing on all the implications that access and benefit sharing, including Nagoya Protocol, have on our activities. So we are working together with the European Commission on providing advice on development of approaches to access and benefit sharing for the Commission. And we have submitted a best practice on ABS to the Commission for approval. Now, we're going to keep on working on this because we do think that access and benefit sharing is extremely important. We're organizing working groups on this with terms of reference, governance bodies, and so on. We're going to keep on liaising with policy decision makers in part of negotiation on ABS. We're going to provide guidance and training, very important, training to our members, to the scientists and the para-taxonomists and the lay people working together with us on access and benefit sharing, so to make sure that everything works within the correct legal framework. And we are going to work as well on other legal issues related to our work, such as intellectual property rights, patents, invasive alien species, things like CETAs, and so forth and so forth. To give you an example, here is the draft, the Code of Conduct and Best Practices of our CETAs, which has been submitted to the European Commission as a best practice approved. Now, the strategy group is looking forward to what is going on in the world. We want to establish a roadmap on where we want to go with our research and our activities. And there we have, again, a strategy document, which basically says that, well, if we want to go on working, we need to prepare for the future. We have to recognize our responsibilities as major natural history, historical natural history museums in Europe. We are a leading body in taxonomy, systematics and natural history collections. So we have to advocate the value of taxonomy to science and society. We have to reach out, not only do our research, but also try to explain why this research is important. And of course, we will be doing our research. We will be exploring and documenting the diversity in nature. And then we're not only doing taxonomy, we're not only trying to explain why taxonomy is relevant, we are also putting taxonomy in a societal context. We want to make sure that taxonomy benefits society. We want to use taxonomy as a tool to reach sustainable development, sustainable use of biodiversity, and we are also, as we are working within a societal context, we are very keen on doing responsible research, which takes into account all societal rules in which we have to function. Now, for that, this vision has recently been reformulated in the Bratislava Declaration, which has been issued yesterday. So this Bratislava Declaration, the text of that you can find already, I hope, on the website of the GTI. Thank you, Junko, for doing this so quickly. And there you will find our main goals, and I strongly invite you to read it. It is a very interesting document, and it gives you an idea of our common understanding, common vision of what we want to do in the future. We have, in this vision, we have 6 key strategic focal areas on which we work on, in which capacity building, training and e-learning is extremely important. Research, of course, is very important, especially trying to open up new tools, offer new tools, new approaches in science to taxonomy. Collections management and access to the collections is extremely important. We are collections managing institutes, so this is extremely important. Science policy and indicators, we are not working in an ivory tower, we are working within a societal context. We are working for the benefit of society. So science policy and indicators are important. Communication, public outreach, and societal relevance are extremely important. And then, of course, bringing this all together, providing access through biodiversity, informatics, and information technologies is one of our main key strategic focal areas as well. And for those, we need to make sure that all these strategic focal areas do not contradict each other, that they build together, that they are coherent. So we are taking all these steps together for a future. And this is one of our, what I'm now going to introduce are some of our new developments. I've had some older initiatives. Some of our new developments is we are involved in one of the European Strategy Forum on Research Infrastructure, ESFRI, programs, as a research infrastructure on collections and taxonomic research, the DISCO, the Distributed System of Scientific Collections. This is a very new development, which in fact builds on the fact that, well, there are things like large infrastructures which we need to do certain types of research. There is the internet, of course, this is a research infrastructure. There is all these large infrastructures that are needed for physical research, but actually we are also one of those large infrastructures. And recognizing this made us produce this research infrastructure, which DISCO is, again, a grouping, but on a far stronger legal basis, grouping 150 national facilities in 21 countries. And this is actually the largest ever formal agreement between national science collection facilities. It's, again, a system of distributed facilities, but with a centralized shared governance model, which is different and much more formal than previously. It's a new business model. It's not only bringing together different collections, but it is bringing all these collections together in one European collection, one single European collection of scientific assets, with a common strategy, with economies of scale and scope, with monitoring, with specialized strategies when necessary, and with joint research agendas. This is very recent. The decision to have this joint initiative, this ESFRI initiative, was made in June 2018, which is fairly recent, if you allow me to say. This was formally announced, quicker. Has to be formally announced in September, but now we're still working on finalizing the things. I will very briefly give you 3 examples of new projects which have already been introduced within this DISCO project framework. The first is the so-called ISDIG, which is about digitization, which is about using new techniques for digitization within our institutes. So to give you an example, these and has been digitized, used established technology which gives you a 2D image, a photograph, a very high resolution photograph. However, with emerging technologies, we can make a 3D module which not only gives you 3D but also internal and external structures. That is the IceDig project. The second is Mobilize, which is about mobilizing data, policies and experts in scientific collections. And this is about streamlining collections management, streamlining expertise, and bringing these collections, making them available, making them accessible, and doing education and training about these things. Third is Synthesis Plus, which is basically bringing our infrastructures together and doing, making access possible, doing joint research activities, and also making all these things. A lot of capacity building goes on in Synthesis Plus. So this is about 3 examples only. If you want to find more about this, please visit the DISCO website. And what is important is that, well, there's another new and greater challenges coming up, which we can only address by building partnerships and inviting everyone to get involved. Thank you very much.
Thank you, Frederick. Any comments, questions for this? Yes, please. Can you use that microphone, please?
Thank you for your presentation. In Tunisia, we are working on banning plastic bags in order to encourage biomaterials for composting process. What are the possibilities that can be offered in order to know which material is really compostable? If not, we have to wait 6 months or 3 months in order to make laboratory researches. Thank you.
Wow. First, that's a very interesting question indeed. What we are trying to do is to make all our facilities, how would I say this, discoverable. We are doing efforts to make sure that you can discover whatever scientific services available through internet resources, which makes that it's much more efficient for you, for example, to find a laboratory with which you can collaborate. That is one thing. There's also the accessibility to data, and which would, if you make an analysis of local biodiversity, it should enable you to much faster make comparisons with already known information that is available in our institutes through the internet.
Okay, today we don't have any microorganisms collections representatives, but perhaps that's another area that museums team will collaborate with to answer that type of questions for those with environmental waste and other environmental issues for the understudied group of organisms.
Sure. Now, the range of institutes within the consortium is quite broad, and there are already collections of microorganisms and related in CETA involved. So it's not only about animals, plants, it's also microorganisms, it's everything that's alive, or that has been alive, basically.
Thank you very much. Okay, thank you, Hendrik, for the very comprehensive collaborative work in Europe. Now we would like to invite Mr. Tim Hirsch. Tim is a Deputy Director of the Global Biodiversity Information Facility, GBIF Secretariat, since 2013, and he is also leading the participation and engagement team. His background is communications, having provisionally worked as an environmental correspondent for BBC News and subsequently as a science writer
for the Millennium Ecosystem Assessment. He was contributed by the CBD Secretariat and to draft both GBO3 and GBO4. So Tim, your talk will be on informatics for the post-2020 biodiversity framework.
Yes, thank you very much for that introduction, Junko, and I'm very pleased to be here in Sharm El-Sheikh for the first event of many over the next 2 weeks, and I think it's going to be a really interesting and exciting meeting for all of us. So the title that we've given for this talk is Informatics in Support of the Post-2020 Biodiversity Agenda, as Junko mentioned. But maybe in these days when we're encouraged to avoid jargon and acronyms and use everyday language for better communication, perhaps that's might be a summary of what I'm going to be talking about today. That's when I use the word nerds, that's not meant in any kind of pejorative sense. What I'm trying to get over through this is that really what we're talking about here is the really exciting time we're in, I think, now, whereby the power of information technology and the way in which new generations of scientists and experts are ever more comfortable with handling data and sharing data, I think offers up to us real opportunities to contribute through informatics to the kind of transformational change that's necessary to address the biodiversity issues that we're going to be talking about over the next 2 weeks or so. So what GBIF, the Global Biodiversity Information Facility, is really about is what I'd call the power of sharing. To bring together people from all around the world who increasingly recognize and understand that the sharing of data and information adds to its value, and that the failure to share is creating a major wasted opportunity for us to have the kind of information we need and in the form that we need it in order to be able to better inform decisions about the management of our living planet. GBIF itself is an intergovernmental collaboration going since 2001, currently bringing together just about 60 countries and more than 1,300 institutions around the world who have all, in one way or another, bought into and recognized this value of the power of sharing. And during this year, in 2018, we passed a symbolic milestone of more than 1,000 million species occurrence records being brought together through our global platform. What do we mean when we say species occurrence records? It's documented evidence of the occurrence of an organism in time and space. And this is coming from many, many different sources. It's coming from the kind of collections that we've been hearing about just now, museum collections around the world, evidence that's been collected into those museums and institutions over centuries, but brought together also with up-to-date scientific sampling and research, including, of course, the molecular sampling of the environment through DNA sequencing, as well as, and this is critically important to understand, a very big contribution from citizens, volunteer observers through large citizen science networks. So all of that 1 billion number you see there is a combination of all of that brought together in common formats so that it can be unlocked and used by science and society. So it's been recognized in the development of indicators for the current strategic plan that the mobilization of that data in itself represents an important contribution. So that within the indicators assembled through the Biodiversity Indicators Partnership, the mobilization of data, of species occurrence records through GBIF is accepted as an indicator of progress towards Target 19, which is about the sharing of knowledge and technologies. The chart on the left is our sort of classic chart showing the accumulation of species occurrence records from 2008, when we first started global indexing, up to the present. You can see it's just crossed the 1 billion mark. And you can see that's been a somewhat accelerating curve. On the right, what you're seeing is the accumulation of species as represented in those records. So in other words, species for which we have at least some evidence of occurrence. And you'll see that's coming up, that's at about the 1.6 million figure. And you'll see the difference is that that's a kind of steady accumulation rather than the more accelerating curve. So we're increasing our coverage, but at a relatively steady rate. So there's a question for you. This is the distribution or the concentration of records shared through GBIF around the world. And so the question is, what's wrong with this picture? Any volunteers? Yeah. Yeah. That's the answer was North Africa, which is a very good answer to that question. And yeah, I mean it's obvious that what this represents is it represents the concentration of effort in terms of sampling of species, whether through citizen science or through collections. Now there's more. If you go to higher resolution, it's not quite as bleak as it seems, but you're absolutely right to point out that there's one region there that obviously stands out. North Africa has a very low concentration of records shared with GBIF, along with some others. But the overall message from that is, if you looked at that, someone came down from another planet and looked at this and said, okay, this is our best representation of species occurrences on planet Earth, they would say, oh right, okay, so the hotspots are in North America, Western Europe, and of course we know that's not the case. So what that represents really is the fact that we have a great imbalance of where the very intensive sampling is. It's getting better, we are getting to many more parts of the world, but that just in spatial terms shows that there is a big mismatch between where we have lots of records and where there is lots of biodiversity. If we look at that, it's the same records, it's the 1 billion records, but just looking at it from the point of view of taxonomic distribution, you get a similar imbalance. Because as we know, for example, birds observation is carried out at vast numbers and volumes and quantities, which means that if you look at the circular chart on the right, most of what's in the green part is birds, with a little bit of other vertebrates making up the rest of that green segment. And then the yellow is showing arthropods, mainly insects, and a lot of that Lepidoptera. And then you have the black is plants, flowering plants. And then that little segment at the top is the rest of the tree of life, right? So just in terms of volume of records, there's clearly, and this is for reasons we all know about, and was actually referred to in the minister's speech from Costa Rica, that our effort is concentrated on a small area of the tree of life. So it's a big challenge for us to even up both the geographic and the taxonomic sampling and representation so that we get as good as the birds. It's not that we don't want data on birds. It's fantastic to have that coverage, but we need to scale up representation of other sectors. That sort of unevenness of representation has been shown. There was a recent study which actually looked at the bias, the taxonomic bias you get if you simply look at number of records in GBIF. And the vertical line down the middle is the ideal state where, based on the number of species in each, of known species in each class, that would be the number of occurrence records there should be if you were going to have even representation across the tree of life. And what you can see from there is that, relatively speaking, birds and some other groups are in the green area are relatively overrepresented, and then other classes with insects at the biggest level at the bottom are underrepresented. So again, it's another representation of the challenge that we all have to try and bring in data that's going to even up that bias. And part of that is going to be bringing together different technologies and different approaches of how we represent data and what our sources of data are. And part of that, and I'm going to just spend a little time on this, is how to bring together the classic way that we organize our species data in GBIF, which is through Linnaean-based names, and then the wealth of DNA-based data that's coming in from many different sources and will be coming in at increasing volumes. And one area where I think this is critically important to improve this linkage is in the fungal kingdom. Just looking at what we have in GBIF at the moment, so there are 15 million occurrences out of 1 billion, split between observations and specimens. A reasonable proportion of those are georeferenced, and we have actually nearly 1 million fungal images shared through GBIF, representing 217,000 species. However, we know that that is a great underrepresentation of this critically important kingdom in the tree of life. And one of the characteristics about fungi is that they contain many what are sometimes described as dark taxa. Taxa within the fungal kingdom that can't easily be described or identified through standard taxonomic techniques. And the consequence of that, and this is where it sort of links into what, the vision of where we need to go in terms of better conservation and management of biodiversity, is that means that, and this was again I think a point that was made very strongly in the context of Costa Rica, you have a large area of diversity which is simply ignored and left out of management. I've been told to speed up, so I will. So I'm going to briefly just touch on an initiative that we have partnered with a group of a mycological community known as the Unite community, which has developed the idea of turning about 800,000 sequences into a clustered system to provide species hypotheses. So in other words, mapping out clusters that are within a certain closeness of genetic characteristics. And through that, they have produced 73,000 species hypotheses. And to provide a sort of a working name, if you like, for each of those species hypotheses, they've used a digital object identifier, which they've assigned to that species hypothesis. And they become what are then known as operational taxonomic units that can support discovery and description. Our partnership with this group has enabled us to recognize those species hypotheses, which are really just here a representation of the DOI, the identifier that links to that particular genetic cluster, with our own taxonomic backbone where we can understand it by relating it to Linnaean names. And we've gone through all of the Unite species hypotheses so that we now can recognize that coding as a name to fit in with our backbone. And that's been tried out in a particular project called BioWide, which is an environmental DNA fungal data set in Denmark, where a lot of the data is, for example, from sampling, from soil sampling, so DNA sequences of soil sampling, where all you've got is you've got the sequence that can then be clustered and put into this UNITE reference and given a DOI. And what we've been able to do through that is then using this particular data set to actually express and represent the individual organisms that have been identified in this sampling simply by their genetic cluster and relate it to where we understand it to be in the taxonomic backbone. And the practical benefit of that is that looking at this particular case of the fungi in Denmark, it enables us to assist with a much truer representation of the diversity of, in this case, fungi in that through those samples, by looking at, well, where are the occurrences of these particular operational taxonomic units, rather than just looking at the nearest species or genus that we can relate it to. And that then enables new approaches to conservation by giving access to these dark taxa that as yet don't have a Linnaean name, and put that into that distribution map that I was showing at the beginning. And that's a technique that we hope to be able to scale up and look at other areas of, for example, better linkages with Barcode of Life, and also to the literally billions of sequences in the big DNA repositories that have spatial information. And if we can get much more of that into the GBIF data set, then it will help to really improve our representation. Just two more points. First of all, later in this meeting, we're going to be holding a side event on Wednesday lunchtime to launch what we're calling an Alliance for Biodiversity Knowledge. And this came out of a meeting that Junko was at, and others here, in July in Copenhagen, that called the Global Biodiversity Informatics Conference 2, GBIF 2, that looked at better ways to link together all of the different initiatives going on in different parts of the world, that if there were better connections and better creativity in making all of this dispersed information actually join up into a single seamless system, would add greatly to the value of all of those initiatives. And we'll be giving much more information about that in the side event. But broadly, what it aims to do is to help to bring together all of the different components of what you really need to measure and monitor the living planet. And that includes not just the data and the evidence from the different forms, from the different sources, but also that you may be able to see at the bottom layer what we call the culture layer, which are the enabling factors in terms of open access policies, use of data standards, persistent storage and archives, policy incentives, etc., that are all critical components of being able to improve the coordination of our observation of the planet. And just finally, and I didn't want to, I don't want to sort of downplay this, capacity from our point of view is absolutely critical to all of this. We're just completing, we're into the final year of a 4-year program with the European Union called Biodiversity Information for Development, which is funding 63 separate projects in Africa, Caribbean, and the Pacific. And that has really helped to bring some of the techniques and to build a community of practice in those regions to help unlock the collections and the data that are held in the South, in the global South, and so far, until now, has been very, again, unrepresented in that joined-up system compared to the big collections in the developed countries. And it's been very encouraging to see the sort of new generation of biodiversity informatics enthusiasts that's developing in those regions and many others. And just very one final thing before I finish. Also linked from the website for the forum, CTAF and ourselves have put together a joint statement that we hope will be a contribution towards the current review and consultation that was mentioned at the beginning on the process that starts now in developing the post-2020 agenda. I won't go into detail on it here. I think we can maybe discuss it later, but I would just invite anyone who would like, who is interested, to just look at the kind of components of that statement, and if there are additional institutions that would like to sign on to it, it's something we'd be very happy then to submit into the consultation that expires on the 15th of December. And I'd just like to acknowledge those contributors, particularly to the fungal work that I referred to earlier. So, thanks very much.
Thank you, Tim. And the declaration is available on the GTI Forum website, so you can download it and take a look at. Thank you very much. And any questions from the floor? Yes, please.
Maybe I come here. Thank you very much, Tim, for this very good presentation. I'm representing here the Global Partnership for Plant Conservation. And the partnership is mobilizing partners all over the world for implementing the global strategy for plant conservation. And we know that it is crucial to conserve plants in situ, but Botanic Garden altogether in the world represent a major force, and they hold collections that are really crucial for plant conservation. So I wonder if it would be, if you have liaised with BGCI, which is holding a database on plant species held ex situ. And I think this would be a major progress as well. Thank you very much. And I'm really happy to hear about the launch of this new alliance. Thank you.
Yes, thank you. Well, actually, BGCI are a collaborating partner in GBIF. I think we have had discussions in the past about the ex situ collections, and there have been some issues around the willingness to make that data fully open, actually. But I think it's something that we should certainly continue to explore.
Thank you very much. And so it's really a beauty of GBIF of the, high coverage in terms of taxa, geography, participation, and capacity. So I really wish to continue our collaboration between the Secretariat and the GBIF and GBIF participating organizations. Right now we have a representative of the Egyptian government, so GTI Forum became real with a very generous support from the government of Egypt, so he wishes to give a few words.
Good morning, everyone. First of all, please accept my apology for being late. I was supposed to be here 9:30, but I was grabbed somewhere else and trapped somewhere else. So I'm supposed to be in 5 meetings at the same time. So you can imagine when you use GTI in cloning, it makes a lot of difference now. Anyway, on behalf of the Egyptian government, I welcome you all, and I wish you a very, very good workshop. I don't need to talk about GTI, but it is very clear that it's one of the most important initiatives of CBD, and it helped a lot because all of us, we know taxonomy is not an easy job. It is tedious, it is laborious, it is time consuming, whatever. But with the advancement of the, and unless if you are really, and as you know, in many, many places, most of the good taxonomists have gone. I mean, I personally, whenever I go to the British Museum, for example, now, most of the good ones, which they are part of the institutional memory. It's not only specimens, whatever, most of them are gone, and the museums couldn't actually continue hiring these good people, and the new generation are not the same. They are not very keen to go for traveling and get many specimens, whatever. But with the advancement of technology now, with the use of barcoding and all of the goodies that came out of GTI, and certainly CBD represented by Joker, is a lot of good things have been done. Not only in terms of capacity building and training and whatever in various places, but we took the opportunity to prepare this. How long we have been involved in this? 6 months now? Almost 6 months. Since June, I think, many communications, and that's why I asked Dr. Sami to be representing me in many of these things, because I'm so busy with hundreds of things. So welcome, Tim. I wish I could respond to all of the good points that you have raised. Where's Tim? Yeah. But you need to sit with this man sitting there. I don't know whether you know him or not, Dr. Kamal Shaltut. You need to sit with him because he made a fantastic study where he reviewed all MSc and PhD that came out of Egypt from the universities or whatever over the last 20 years. So that helped us to increase our knowledge about biodiversity, not in terms of species. The species, they have increased by almost 30% to a great extent. Especially, he's a botanist, so a lot of work. I mean, if you take something like fungi, 2,449, if I still remember. That's almost 8-9% of the whole fungi in the world. We have some species of, I think, arachnids. They can be as much as 5-6% of the world record. There are very interesting things that came out of Egypt. Not only that, but in terms of ecosystem functions and services, like wetlands, northern lakes in Egypt. A lot of stuff that came out of it, not only in terms of how much in terms of ecological or economy, but in terms of even climate change, carbon sequestration. Records in Egypt have shown that wetlands are very important for that. You need to meet with this man, Dr. Sami. For me, can you raise your hand? Sami is, it is enough to look at that poster. I mean, when I look at it, it reminds me of the good old days, Sami. A lot can be said about butterflies in Egypt in one poster. Not only about the current situation, but the future. And that's what we are trying to do. The goodies that come out of GBF, and all of the global database that everywhere in the world now, it helps us to predict what's going to happen and what kind of action that you should take. So this is very important in terms of climate change, in terms of very important groups like butterfly. The third person I would like to mention as well, Professor Mohammed Fishar in the back here. You need to sit with him. He brought to me a figure of 411 or 12 species from the latest survey that he did in the Suez Canal regarding the issue of alien species, whatever, etc., and the information that we are getting in Egypt now about that issue that became a controversial in many ways and became, in this species, became almost a political issue, and we have done a good work. And you have provided me with a lot of good books, because the issue of invasive is not enough now. We are talking about beneficial species, because some of them, they became very commercial. Some people talk about them as adaptive species, but certainly Dr. Kamal Shaltut's daughter made a fantastic study on the vascular plants. She evaluated, I think, 136 species, and, sorry? 200? Yeah, and only the invasive species, how many? 5, 6? Yeah? 7 species of plants as well. So we have much better data than a few years ago. So we need the interaction between all of you, and I hope more chaps from Egypt will come to this important workshop. I have to dash very quickly to another meeting where I'm sharing, and I took the opportunity just during the coffee break. So good to see you, and I'll do the best I can to come and join this very important workshop. All the best. Thank you.
Thank you very much, Mustafa. And well, we will move to the different region now. ASEAN region. The ASEAN Center for Biodiversity has done a lot of job in capacity building and communication for parties to be able to implement their NBSAPs. So now Dr. Filberto Polisco is taking the floor. And from now on, every speaker, please make sure that your presentation will be finishing in 15 minutes. Thank you.
Okay, good morning. Thank you, Junko, for inviting us here. I'll be sharing our activities that we have done in Southeast Asia for the past 7 years, since 2010. And we were supported by the Japan ASEAN Integration Fund, and we have partnered with the Ministry of Environment of the government of Japan since 2010. So, anyway, what we've been doing in taxonomy capacity building, this addresses the following HE targets. Target 1, Target 9, 11, 12, and especially Target 19 for knowledge shared and applied. Now, these are the training courses that we conducted from 2010 up to 2017. We started out with, of course, the inception meetings and workshops to fine-tune the training programs. But we started out with corals taxonomy, and we also looked into the taxonomy of threatened species for CITES, especially the reptiles. Then the basic plants, basic taxonomy for dicots, monocots, and we also had this internship program. So it's not only the lectures, but we also have to do the hands-on application of what taxonomy is. Now, well, you can imagine we have 10 countries, we have 10 cultures, we have 10 languages, trying to understand taxonomy in English. So it's a very difficult thing to do. But of course, we also have some partnership with ESABI. This is the East and Southeast Asia Biodiversity Information Initiative, also by Japan. And we also went into the taxonomy of freshwater, brackish water fish. And our field exercise was conducted in the Mekong River. We also included in our training programs the communication, education, and public awareness for taxonomy and biodiversity, and came up with CEPA action plans. And we had the media people and the communications people attending this training workshop. And graduating from the basic taxonomy of dicots and monocots, we went into the more specific plant groups like bryophytes and pteridophytes. And we also went into the taxonomy of economically important insects, predators, and parasitoids. And then some advanced courses on, again, pteridophytes and bryophytes, including data organization. Because we discovered that these participants, they are more on resource managers and academicians rather than scientists. And they have to come up with information and then feed it to the information technology people. And therein lies the gap, because the information generators do not understand the language of the information technologists and vice versa. And we tried to bridge that gap by inviting these people, put them together, and then let them work together on taxonomy. And I will show you later the outcome of that. And We had some workshops also on ASEAN Heritage Parks development and protected area management with some insertions of taxonomic activities in those activities. And again, methodologies on biodiversity assessment, data gathering, communication and education, public awareness, and all of these things. And we also have taxonomy and mycology of large fungi. Okay. With ESABI, with our counterparts in Japan, we looked into the large fungi rather than the microscopic fungi because they are easier to find. Okay. And then our latest is the capacity development for the taxonomy of high elevation vascular plants. Now, all of these activities that we did, women make up about 30% of the participants. Unfortunately, we could not get participants from the indigenous peoples and local communities because it is the countries themselves who nominate the participants. You know? And most of them are from the government, from the academe, and from protected areas. Okay. Our first attempt, now this is the good practice that we did, our first attempt in having an output for the participants was for them to individually come up with a draft scientific article. And we realized that these guys are not scientists. These are not scientists. And we tried to teach them the rigors of coming up with writing scientific articles and such. And eventually it became a failure because, number one, language was the most difficult barrier to overcome. And then since they are not scientists, they are not used to writing, then we had a difficult time editing their work, and they had a difficult time writing their work. So our resource persons had to have an overhaul of thinking on how to make these taxonomy trainings attractive to these non-taxonomy people. And the next year that we did a second attempt, we came up with a field guidebook. And these participants, we made as contributing authors in their assigned plant groups. And these now became the incentives for the participants to really go into these taxonomic exercises. But of course, they have to be supervised by senior taxonomists, because we could not just let them be and write anything they want. Because this is a taxonomy exercise, then they have to be supervised by these senior taxonomists. And after the workshops, we had to have at most 3 write-shops to fine-tune the guidebooks, okay, so that it will be internationally accepted when we publish those field guidebooks. And these are the guidebooks that we came up with. This one on the right, on my right, the monocot plants, that's the first attempt that we had for a field guidebook. And then the rest, we became more apt in developing the field guidebooks. So we have, our best seller is the bryophytes and the pteridophytes. Yeah. And our latest guidebook, Field Guide to the Vascular Plants Along Nature Trails on the summit of Doi Inthanon National Park, Thailand. This is the high elevation vascular plants. And we had our exercise in field collection, field identification, etc. at 2,500 meters above sea level. Okay. Okay, so these are the senior supervisors and authors, among others. And as you can see, we have a diversity of taxonomists coming from different institutions in Southeast Asia and also Japan. So we have one from University of the Philippines in Los Baños. We have the Royal Forest Herbarium in Bangkok and Queen Sirleaf Botanic Garden taxonomists. Then we have Dr. Tet Yahara in Kyushu University, and by the way, Dr. Yahara is a GBIF member. And then we have Dr. Tanaka, and then some from Indonesia, and also from Malaysia. And I think many of you know Dr. Benito Tan. And he is our foremost bryologist or bryophyte expert. And unfortunately, in 2016 December, he passed away. So I just want to honor him here in this forum by putting in a picture of that. And one of the last things he did was joining our taxonomy training. And he has this dedication and professionalism in really teaching our participants on the rigors and taxonomy of bryophytes. And out of the Japan-ASEAN Integration Fund projects, we came up also with the Regional Action Plan for Southeast Asia 2017 to 2025. So this is already post-2020. Okay, and we have to align this action plan with our ASEAN Strategic Plan for the Environment. And we also did some impact assessment of these capacity building activities from 2010 to 2016. Yeah, so lessons learned, these are the things that we learned, of course, the language, and published tangible output as an incentive to the participants. And it is very good to have internet connection, library, good herbarium facilities, and presence of experts. 15 years ago, we cannot do this. But now we can do it. And of course, a field guidebook is a simple output which participants can relate to and easily do. And participants may not be 100% with taxonomy background, but understandable and simplified explanations can compensate for the inadequacy. Again, this one's a nice one. Let the taxonomy bug bite them, and they will take a natural course in replicating what they learned. Because if they enjoyed what they did and they have an incentive seeing their names published, then it's a natural for them to follow through in their own countries. Okay, so some findings in the impact assessment. We have increased confidence of the non-taxonomists. We have recognition of additional experts, and they gave their bosses gave them additional responsibilities because of it. I don't know if that's good or bad to the person. And then the expansion of knowledge, some revision of conservation strategy in their protected area management plans. And then they have a development of taxonomy publications also. They gave them the confidence to develop these pocket guidebooks. Increased pride and appreciation for biodiversity. And then this one, contribution to new scientific discoveries. Because I'd like to emphasize on this one because one of our participants, when she selected an herbarium specimen, and when she was trying to describe it, she realized, and the senior taxonomist realized, that this was a new species that was collected in 1950, and it was just buried under the different specimens in the cabinets of the herbarium. And so she had them, she went through with the description and had it published in Q Bulletin in 2014. Okay, further collaboration and network. We now have an informal networking in the social media because of these participants contacting each other. Increased funding, staff, and equipment for taxonomy executives. Two more slides, this one. Feedback from the participants. I'd like to share with you this one because it's very interesting. See? Preparing the guidebook together with other participants that are not from the same botany background was very interesting. They helped to capture interesting plant characters that are often overlooked by the botanists or taxonomists, and they also assisted in reducing botanical technologies or terminologies used in describing the plants into more understandable language. Okay. And another one, the last slide from Lao PDR, the knowledge that he got from our taxonomy trainings, he was assigned an herbarium and he did not know what to do with it. And after our training, now he's collecting and doing things to improve his herbarium in his university. So, with that, thank you, and may our tribe increase. Thank you very much.
Thank you very much, Noi, and it was very practical and connected with the people on the ground. That is very interesting. Unless you have a desire to ask questions, time is limited, so is it okay to invite next speakers? There will be three Global Taxonomy Initiative DNA trained trainers. They're going to present the 10 projects that were implemented within this year in all different parts of the world. So the speaker will be Dr. Jamila Ibrahim from Nigeria.
Yeah, good afternoon, everyone. I'm making this presentation on behalf of 10 GTI project leaders. Three of us are here. I have Mona from Tunisia, Tatiana from Belarus, and I'm Jamila Ibrahim from Nigeria. The presentation is on the GTI DNA Tech Training Workshop that was held in 2018. Its immediate outcome, sustainable plan developed by the trained trainers. My presentation will be covering those aspects. Brief background of my presentation: taxonomic needs identified, the tools to solve those taxonomic needs, and the capacity building in that area. That is the training itself. What is the taxonomic need? The problem. This is identified by parties to CBD, the countries which are parties to CBD. Some of us are from those countries. We identify it as taxonomic impediment as one of the reasons in achieving our biodiversity conservation and sustainable use of our biodiversity, especially in the area of correct species identification, priority species that is peculiar to us, invasive alien species, for example, endangered species, for example, agricultural pests are also inclusive. And this will be a problem for us who will not be able to put up early detection program to be able to detect and quarantine some of those priority species. We'll not be able to develop rapid response if we don't have correct identification of those species. Appropriate management measures will not also be able to be put in place for eradication, control, and protection, especially of our endangered species or species of priority to our various countries. So what is the solution we propose? We looked at it and felt DNA barcoding is one of the solutions to solve our problem. DNA barcoding, as we all know, is use of short DNA fragment to identify unknown specimens. Why DNA barcoding? Fast, accurate species identification, cost-effective, very minimal laboratory workflow needed for us to be able to achieve that. And also one of the very important advantages that we should take note of is the fact that we can use fragments, piece of sample to get DNA sequence for our species identification. Yes, especially when you're dealing with not invasive species, endangered species that always be shipped from our country in piece or in fragment. It can be used to identify animal and plant and fungi species, very important to us. And also, because it's a prerequisite for species identification, especially if you're dealing with environmental DNA. You want to take samples from environmental DNA, you need to have a rich library where your samples can be queried and you're sure your specimens is identified properly. So, in looking at that, there was a gap that was identified. Inadequate of expertise in DNA technology, especially in developing countries where we're from. That expertise is, in a way, lacking enough for us to be able to achieve DNA barcoding in our various countries. So capacity building development is needed to be able to solve that issue. DNA barcoding and capacity building related issues were also recognized by the CBD. COP13, about 2 years ago, recognized that aspect, and a decision was taken to be able to propagate and support DNA barcoding technology and its related biodiversity, capacity building related issues. So what do? The GTI DNA Tech was born, and these are the focus of GTI DNA Tech. Train the trainers. 2, learning by doing. 3, standard workflow in DNA barcoding. Basic laboratory infrastructure. Basic data analysis, especially the use of Barcode of live data system. 4, project formulation training and project management training. That gave rise to the GTI training program, which were in 2 phases. The first phase took place in 2015-2016, and the first phase was tied to the GTI training course on rapid identification of invasive alien species for achieving ACCID Target 9, while the second phase titled Filling Capacity Gap for Application of DNA Technologies in Taxonomy. GTI training workshops driven by the trained trainers took place 2017-2018. This is the general overview of the first and second phase of the training program. In 2015, the CBD called for nomination from developing countries and countries with economic transition to send in their nomination for training in GTI, Global Taxonomy Training. What happened? 93 countries sent in their nomination. All the colors you see represented all the countries that sent in their nomination. The yellow, the green, the blue, and the purple colors represented all the countries, the spread of the countries. Out of that 93, 52 were selected after rigorous exercise to undergo the online training course, which took place in early 2015, for about 8 weeks. Online training course for those 52 countries for about 8 weeks, hosted by the University of Gulf. And out of that, so the colors, green, blue, and purple, were all those countries that participated in the online training course. Out of that, 29 of those were also selected from the 52 to go ahead to University of Gulf to undertake a hands-on training course for about 4 weeks. That was also hosted by University of Gulf, and that gave rise to 29 trained trainers between the year 2015 and 2016. Then the second phase took off in 2017. Towards the end of 2017, the CBD called for nominations again, this time around for countries in the developing countries and countries in economy in transition, especially countries where those trained trainers, the 29 trained trainers, were produced to send in proposals for them to also duplicate the same training technology, the DNA technology they had in Gulf between 2015 and 2016. Nominations were sent in. Out of those nominations, 10 countries, that is those countries in purple, were successful at the proposal selection exercise. And out of that, these 10 proposals were sponsored through the fund from JBF, Japan Biodiversity Fund, to carry on with the project. The project took place 2018. Some of those countries involved are still currently undertaking their project. 8 of those projects were national training projects. Bhutan, Colombia, Nigeria, Philippines, Sri Lanka, Suriname, Turkey, and Uruguay were national training programs, while 2 were regional training programs. The Tunisian program covered the Francophone North African countries, while Belarus and Moldova program covers the CEE countries. Mona and Tanya is here to give you more information, if required, on the regional trainings. These are images from those regional trainings. You can see some of those images were from public awareness program, and the second image is also from the training program. We had the awareness program right from Symposium, the laboratory collection and documentation aspect, the laboratory processes, PCR, DNA extraction, gel electrophoresis, DNA sequencing, use of BOLD database network, and bioinformatics. So those are images from all those programs. What are our achievements? From the trained trainer program, the 10 project, a total number of 166 trained trainers were produced from 91 institutions in 18 countries. We are also able to initiate DNA barcoding libraries for priority species. These priority species are to address this area was to answer most of our NB-SAP target. And those priority species either covers invasive alien species, agricultural pests, endangered species, our aquatic environment species, and all that. So all those covers are represented in our NB-SAPs. And for your information, all those NB-SAPs are aligned with most of the ACI biodiversity target. So a total number of 510 records were uploaded into board. Those records are either new species added to board, some are new species occurrences for some of our countries, some are new barcodes for our countries. In-country capacity assessment were also maximized. We're able to assess, we're able to put in place the channel on how to assess our equipment, reagent, consumables, and sequences, which could be a major impediment to DNA technology in our countries. Why? How did we achieve all those? How did we make all those achievements? What are our strengths? Yes, our strength, the CBD focal point engagement throughout this project was one of our positive achievements. There are various CBD focal points they were with us right from the proposal writing stage up to implementation of the project. National and regional networks that were established, experts from various fields were also involved, interdisciplinary entities engaged. We didn't just stick with scientists from our field. We went ahead to involve government agencies, researchers, academics, various taxonomic experts, local communities, fishermen, farmers were all involved, private sectors, Inkaba Biotech, so for sources of our raw material, our reagents and consumables, NGOs were all involved. All this contributed to our positive achievements from the project. What is our plan to sustain this project in our various countries? Develop projects beyond the environmental sector. Currently, some of our countries are already in negotiation with regulatory agencies in our various countries to go into negotiations, especially in setup of our institution as a reference laboratory facility for diagnosis, especially maybe invasive alien species or for confiscated materials, especially in the area of endangered species. We also intend to develop international collaboration, especially to increase the coverage of African species in bold. We are all aware that most of our biodiversity hotspots are found in developing countries where capacity for DNA technology is minimal. We also intend to incorporate DNA barcoding into university curriculum. We intend to find a way to incorporate that into university curriculum so that our future users of this technology, our future strain trainer, will have the basic knowledge right from the beginning. We want to continue public awareness campaign. We want to promote citizen science. And also, this will also help us to provide support and evidence for policymakers, as the policy-making process involves decision from those of us who are scientists. They will need to know what to protect and how to protect it, and what those organisms that needed to be protected, where they are found. Yes, our take-home message from this. DNA technology is currently gaining ground in biodiversity conservation and its sustainable use. But for Africans, for developing countries, we're saying DNA barcoding is an entry point for us to build molecular capacity in DNA technology. Yes, we want to acknowledge these various CBD focal points of our countries: Belarus, Moldova, Bhutan, Colombia, Nigeria, Philippines, Sri Lanka, Suriname, Tunisia, Turkey, and Uruguay for their support from beginning up till now. We also hope for their continuous support in achieving our next goals on our next target. We want to thank Japan Biodiversity Fund, who provide the fund for this training. Without that fund, we will not be able to achieve what we have achieved so far. We also want to thank the CBD GTI group, especially Junko Shomura, for her continuous support. She is the coordinator of all the training programs. We want to thank this technical support, the University of Gulf, especially Adriana and Alex. They provided all the technical support for us for this training. We want to thank the individual technical support we got from our various countries too, regional, national, in-kind support from our institution. We also want to acknowledge that. Without all those put together, our achievement would not have been so laudable. Thank you.
Thank you very much indeed. And well, I apologize, the time is very pressing, so unless Flora has a question. Oh, okay, Tim, please. Just short, quick question, please.
Yeah, it was really just a quick point to make. That I think it's great to see these projects supported under the GTI umbrella. I think one of the things that's really critically important is that this kind of training effort related specifically to barcoding is put together with other training, such as, for example, the one I mentioned of mobilizing data from collections and biodiversity informatics training in other forms. And there was a recent very good example of this, in fact, at a workshop at Lake Baikal in Russia, jointly organized by Russian Academy of Sciences, for Bio, which is a Norwegian-based fund, and GBIF, where we actually held side-by-side training of, on the one hand, the barcode training, but also then the data mobilization through GBIF training. We found that was very effective, and I think going forward it would be great to see how we can better integrate that quite specific area of skills relating to barcoding with other forms of data mobilization, so that we don't have these kind of silos developing in terms of capacity building.
Thank you very much. Very important comment to collaborate with the different donors and different organizations and breaking silos. And you done the very good job and broke silos only within 1 year this year. Thank you very much, all those trainers. Not only 3 of them, 10 of them. Oh, do you want to say? Okay, just brisk, please.
Thank you for all your efforts. What are the next steps?
Thank you very much. So, if you look at the last slides, we look at sustainability, how to sustain this. There were a few things we mentioned. Continuous training, we just mentioned few because the time left for us to present are just short. So there are several next follow-up activities. All those 11 posters you can see behind are 10 posters are from those training. If you look at them, you see the follow-up, the next step activities by each country. But in overall, we have programs to continue training our younger ones in this technology. We also want to intend to continue to negotiate with government on a way how this can be included in decision making. Include DNA barcoding as a tool, especially in identification of classified specimen. So we're also looking at that and several other things. But you can look at the posters and you see more of those follow-up activities. Thank you.
Thank you very much indeed. And we would like to invite Egyptian Sustainable Training Development for North Africa. Professor Zami Sarat will make this presentation.
Yeah. Hello. Yeah, my name is Sami Zalat. I'm going to talk about taxonomic capacity building or development in Egypt and North Africa. I'm working as a professor at Suez Canal University, and I'm a chair of one of the NGOs working in biodiversity in Egypt. It's called Nature and Science Foundation. North Africa. As we can see from Jeff and as well as from barcoding, there is a great gap in North Africa and the Middle East. And a piece of always is lacking this area, although it is a very important area. It is a region between Afrotropical, Palearctic, and Oriental region. Even with Palearctic, you can divide that into Sahari, Arabian area, Irano-Turanian area, and Mediterranean area. So it's actually the junction between different fauna and the flora. Very interesting area. Yeah. What I would like to concentrate about the relation between taxonomy and conservation. Does conservation need taxonomy? If so, how taxonomists do the job? To do that in Egypt, In August 2007, we have a meeting, I think, either in Morocco. We have two meetings, actually, one in Morocco and one in Tunisia, through BioNet or NAFINet, North African Network for GTI. And we agreed at that time on two projects, training the people on pollen, barcoding of life, and as well as establish a biomap project in these North African countries. What are BIOSCAN or iPol and biomap? My colleague, Dr. Mehradad, will talk about BIOSCAN in the next talk. What I'm going to talk today, or in my talk, about biomap. Biomap is a project called Biodiversity Mapping and Assessment Project run in Egypt within 5 years from 2004 until 2009, funded by Italian cooperation, and actually the main objective is to fulfill the obligations of the CBD. What we did, there was 4 components: recording and mapping biodiversity, monitoring biodiversity, dissemination of the information, and create what they call a CHM. It is a biodiversity portal. We call it clearinghouse mechanism according to the CBD. And finally, to create the data listing of Egyptian fauna and flora. To create the first one, which is recording and assessment of the biodiversity, you're talking about old records. You're talking about collections. You're talking about herbarium. So we established a national biodiversity database of Egypt. Me and my colleague, Professor Francis Gilbert, unfortunately he's not today, or even in the conference, and we started to create our Egyptian national database. The database, we concentrated on the collection of the herbaria, recording and monitoring, what we call exploring and documenting biodiversity in nature. There's a second one, so we're looking in the past, in the collection, and then dissemination of this information and how we can use this information for conservation. Very easy for taxonomists if they think in that way. In Egyptian record, what we did, we collected all old records, specimen in collection, published material, unpublished report, personal data, new record from the rangers, from public. Very simple data we were interested in. What are the species? It seems very easy, but it is very difficult because you need a good taxonomist to identify the species level and you know these are the right species. That's why barcoding will come and solve all these problems. Where seen, when, by whom. And I said there is a challenge is that, and we try to overcome all of that. Access to foreign museums, we did a great job on that. What species is it? That was an important. Where? The travelers come to Egypt and sometimes they visit Palestine and Iraq and different countries, and they said I collect this from Egypt or from northern Sinai or from Giza. Where you can put this spot in the map? It was a challenge. That's why we created our georeferences area or locality. The database, we working with experts, extract record from museum specimen with an Egyptian collection. We have hired a lot of scientists in the country to collect this data. Some of them are here. Data from specimen from foreign museums through the web, or we even sent some to Smithsonian Institute to have the specimen or the record from there, working with experts to correct identification of the species, creating a georeferences, gazetteer for Egyptian with lat and long for each locality. We have all of that. And upload to the database. That's the past, what we have in our collection. Then we thought about exploring and monitoring the biodiversity, what's going on in our fields. So establish this monitoring program with the help of these people. Ministry of Environment, GEF program, Operational ASEAN, British Council, funded us. Why these people come to us? Operational ASEAN is an international scientific company, is doing hiring volunteers to help countries for conservation. We have a project with them for about 7 years, from 2004 until 2011, and stopped because the political situation was quite difficult. British Council established a new program. We established together a new program called Young Scientists. And we told them, why not? We can have young Egyptian scientists to help us with monitoring program. Nature conservation sector, Ministry of Environment, the rangers, they have no time, they have no money. We said we are coming with you, with the manpower and with the money, and we are going to do your job. And Jeff, small grant program, were interested in the local people, and we used to work with the local people. Here is we did that with marine and as well as terrestrial in Sinai Peninsula. We did that monitoring program for Ras Muhammad and Nab, which is quite close to here. And then we did the desert. These are Operation Lesseya volunteers. Here is Egyptian with international volunteers. Here is the national park, supported us with facilities and with their staff. And then these are local people who try to train them how to, as a like citizen science. That's a team. What we did as a team, you can mix of local people, local people like these guys, Salama, there's Haitham sitting here, and other international volunteers. We worked with plants, mammals, different groups. Plants, mammals, bats, insects, reptiles. We surveyed all of that. We have a very systematic technique to do that all over the South Sinai. We did these expeditions, and these color refer to different years, and we covered all of that, this area of Santa Catherine National Park, one of the biggest park in this area, in Sinai Peninsula. So we covered all of that. We missed these ones, and we're working on these ones now, these areas. That's the output of our report. You can have the dots for Dorcas Ghazal, for example, and then we created a number of layers, which is very important for biodiversity, like habitat layer, temperature layer, topography, soil type. That's the main 4 important layers to predict the distribution. And then if you can have the records itself, then you can predict where is the distribution, where are the hotspots. We did that, and then you can tell for Dorcas Ghazal, that's the hottest area on the Red Sea coast. Here is in the eastern desert, and then less likely to be in this area, and then this area. Most likely you couldn't find any Dorcas Ghazal in this area. That's what we did. We did that for mollusks. And the whole idea about these monitoring and collections is collection of records, then correction the names, assessing the records, georeferencing the records, assessment of record itself, finalizing the data set, producing special maps. IUCN criteria can come straight forward out of this exercise. Then you can have a species richness map, which is very important. Then you have gap analysis. Are your national park cover the hotspots of the area of the country or not? You can test that easily. Then you can produce images. We have some here, and our booth is on the other side, National Science Foundation. If you are interested to have some of the publication, they are there. Then you can set for decision makers the priority list to predict. For example, for butterflies, we did that for mammals, for butterflies, we did that for dragonflies, Odonata, dragon and damsel flies, we did that for a number of families, Labiati, Amaranthiaceae, different families. You can tell the decision makers, yeah, you have these species endemic, critically endangered, this is a priority list. Then you can create for them priority list to conserve and work about. You can have a species richness, the hottest area of this group, and then you can put your national parks, and then you can have what we call gap analysis. That's the kind of thing taxonomy can do for. Our plan is to have what we are doing now as NGO. I'm a professor in the university, so in my lab I'm working, and we are initiating or promoting citizen science. We have a fund now to establish 3 youth foundations to help us. So we are going to do that within the next year. Then all of us will do citizen science. We'll work with experts, with public, with rangers. What the aim is to go and collect data, and then through these data we can feed in the national database. And the national database will go to the server, and then you have the GIS layer which we created. Then anyone in the public, scientist, if he asks for data, he can ask and the data come to him as a metadata or even map data, whatever. What we're aiming for as well, to work on BIOSCAN. That's our plan now.
Again, we are going to collect, put that in BIOSCAN Egypt, I hope in North African as well, go for the national database, and then go for BIOSCAN Global, which Dr. Mehradat will talk about later on. Challenges, a lot of challenges. We need enough and good taxonomists, which Egypt in a good position on that, and we have a very good connection. Citizen science, or promote citizen science programs, that's what we're working now. Collaboration, we need collaboration between government, NGOs, expert, and public. We need fund for field expeditions, producing field guides, and etc. Encourage colleagues from North African countries. The example, the guys given us from Tunisia, we need this experience. We need to exchange this experience. So Tunisia, Nigeria, South Africa, I know South Africa is doing very well with Barcode of Life. So if we can have this connection, then we can move forward in Africa and Mediterranean as well. Involvement of other African and Middle Eastern countries, that's our hope. Thank you very much, and this is our website.
Thank you very much indeed. And any questions? Just a quick? Okay, so next speaker will be the last in this morning. Professor Mildred Hajibabi from Guelph University. He's going to talk about the Breaking Silo Global Project, which is called BIOSCAN.
All right, so thank you, Junko, and the Secretariat for inviting me, and I know that I'm between you and lunch, so I try to be fast and brief. But let me start by showing you this map that I recently took from the news, and this is sort of inspirational for me, you know, like we're heading with understanding and documenting and using biodiversity information. And this map was actually recently in the news, that the new German satellites, you know, can really monitor the surface of the Earth, and the type of resolution that they're getting, you know, is going to tell us a lot about, you know, changes in the landscape in various regions, like the panel here is the Himalayas, you know, on this side, and then the Appalachian Mountains. So this is really, I think, that where we're heading. And these are not sort of static maps. These are very dynamic, that you can even access it in your pocket, in your devices. And as Dan Jansen showed, the DNA technology is moving towards that. But I mean, how are we going to utilize this for biodiversity, and how are we going to generate you know, enough data and high frequency observational data that can allow us to really use biodiversity knowledge and you know, in various aspects of the you know, societal benefits. So that's where I think it's sort of we're hoping to achieve. So when you're talking about the systematically talking about biodiversity, of course we talked about the tree of life and all the organisms. I'm not showing prokaryotes here; these are eukaryotes. But then we've been putting these in the packets of information that are used either for scientific purposes or for societal benefits. And I kind of try to categorize this into these broad categories, like invasive species or pests and pathogens. Sort of these things are like harmful, you know, either to our well-being or to the ecosystem's well-being, which is associated to our well-being. Or there are, you know, other type of targets like endangered species that we need to monitor for various reasons, and or groups like bioindicators that have been used historically, you know, to show us changes in the ecosystems, and groups like climate change, and maybe a kind of a more recent you know, category is food and natural health products, you know, things that we eat or consume for various purposes, and again the authentication we saw in some of the presentations, you know, like these are the categories of information that we're seeking. And I think that a system needs to consider all of these and also the broad tree of life categories. But we also need to consider two other elements, such as time and space. It was mentioned a little bit, but I don't think that we've given this enough thought, because oftentimes when we create a map, we need to think about how can we use that map and how many times we need to go and sample to be able to understand the changes. In terms of biodiversity, I think that we need to give more emphasis on the axis of time and also space, which is then linked to the changes in the environment with climate change, with industrial and other types of activities. So I think that's where we need to put. So this is where it is, in terms of what we need to tackle. Now, barcoding is really not a new technology, and DNA has been used for biosystematics for many, many years. I did my training on microbiology undergrad, and then we were using PCR-based technologies to identify different species of bacteria, different groups of bacteria. This is many years ago. Then moving into phylogenetics and understanding the tree of life and relationships using DNA. What barcoding really did is to standardize and converge on a minimal amount of information that we can then achieve larger goals in taxonomy, in identification and biosystematics, and then link it to ecology, other things. This is the first Barcode of Life, the International Barcode of Life project meeting in 2007 at Guelph, where the sort of a starting point of really bringing countries together and trying to mobilize this project around these goals. In 5 years, we would like to sequence, barcode 500,000 species, and some sort of a cost estimate, which later on with the technologies development and the cost got really smaller than this. And when you think about how these sequences are generated, I mean, I'm going to try to get into a little bit more into details of how things are done, and then sort of expanding in terms of applications. So typically we've been using Sanger sequencing, which is using sorted specimens. So the first order of business is just get the specimen sorted. This is like a benthic sample that like you get for environmental assessment, and I get into that later. But these larvae need to go and get sorted and then go into the channel of sequencing, and typically one specimen gets 2 reads of sequence forward and reverse, and that's sort of it. But since 2007-8, this new next generation sequencing technologies allows us to actually dramatically increase the capacity. And we can use now next generation sequencing for even sorted specimens. So this is something that, like we always thought, okay, next generation sequencing is good for environmental DNA, but now we are tagging every individual specimen with oligonucleotides that then we can then mix them and then sequence them and then retrieve them and separate them. And typically you get 1,000x coverage for each specimen, and you can do multiple markers. And this is remarkable. I think this is going to be very, very powerful in building libraries or identifying single specimens for various applications. This is a small tree that we are showing the congruence between Sanger reads and the SQL PacBio device that we have been operating since 2007. But the other thing that is really important is the cost, that you can decrease the cost dramatically. As was mentioned, in other presentations, that's a huge element in pushing this forward at large scale. And as you can see here on the graph, by incorporating these new technologies, we are and we will continue to increase the capacity to process. Like one of these equipment can process about 3 million or so specimens, single specimens per year. Of course, bringing the specimens, separating them, still a huge undertaking, but in terms of sequencing capacity, I think we have the capacity to scale up dramatically using next generation sequencing. Now, thinking about the target libraries, I really want to bring this to the attention of the audience that we've done a great job building the sequence libraries, but we also need to be a little bit more careful in terms of what we are sequencing. We did a study with my postdoc, Terry Porter, in looking at some groups such as bioindicators and endangered species. This is published recently, and we see, for example, with the IUCN endangered species list, we are not yet there. I mean, we have some key species in the databases, but some large portion of them are left out, or the bioindicators as well. So I think there needs to be good thinking about when the consortium or the groups of countries, come together to build these reference libraries. I think that we need to be very mindful of how we get this, and this is the role of the collections and the museums and so on in providing these specimens is critical. By and large, the Barcode of Life, I think, Another sort of major achievement is a fantastic, I say that because I'm not part of it, is my colleagues running this database data system that is basically the repository and also a data management and analysis platform for this type of information. It doesn't just hold sequence information, it has images, locality information, all sorts of metadata you can bring into this platform and is linked to other databases such as GBIF, GenBank, and so on. And so far, we have over 6 million of the barcode sequences that are associated to about like 570,000 of these provisional species using barcode information. The same thing that we heard from the GBIF in terms of the fungal work. We've been operationalizing this for at least like 6-7 years now that we are using this to deal with the, the fact that many of these specimens may not have names. So we need to operationalize an algorithmic way of categorizing them. And we're not saying these are species, they're sort of hypothesis is a good term for it. But then in terms of named species, we're looking at about 200,000 animal species, about 75 or so thousand plant, and then 21,000. We need to work on some other organisms like protists and fungi, get more of them. But again, this is, and the distribution is, as usual, we know that, like in some areas we have a lot more than others, and these needs to be addressed through consortium and provisioning of samples. Now, moving into a different category of getting information and using the barcode information, in fact, is this bulk environmental samples. We heard about this. This is the type of technique that we've been working on for since 2007 with the beginning of next-gen sequencing. It's called environmental DNA metabarcoding, environmental barcoding, and call it marker gene metagenomics, various names. The idea is that you don't need to sort things. You can access bulk specimens and or environmental DNA, what have you. And then through next-gen sequencing, you can focus on specific targets like DNA barcodes or other markers. And I just want to recognize, one of my colleagues, Shadi Shokrullah, is an Egyptian living now in California, worked with me for 8 years in my lab and in this panel, and he was one of the brains, behind this environmental DNA barcoding that we operationalized. And of course, on the right side, we have Mark Blackster in Edinburgh with the newer sequencing devices that I show you in a bit. Of course, when you get the data, you need to do a lot of bioinformatics. You need to rely on libraries to make sense of the data. So in all of this, like the categories that we've been focusing on in terms of research is to recover the sequences from environment, resolving at the species level, resolving biodiversity at the level that is needed, and then doing better annotation and analysis, and then getting the type of information you need for ecological analysis, environmental, or any other types of scientific or societal benefits. We did an analysis of all the genomics tools that are out there. This is a review article that was published recently to think about how we can scale up and what are the different techniques. And interestingly, again, we and others have shown that this standardizing on the barcode markers using next-gen sequencing technologies together with good libraries, that's the way to go for biodiversity at larger scale. And unlike the whole genome sequencing, which might provide you a specific, very large amount of information, comprehensive information on a specific group of organisms, but it's not scalable at the level that we need to tackle changes and shifts in the environment or invasive species or other types of questions that we have. It's still not there. But I think that by focusing on smaller portions like DNA barcoding and metabarcoding, I think we can scale up with the current technology. Now, how are we going to use this information? Like the bioindicators are really important for environmental assessment and has been used. This is benthic bioindicators from freshwater, and we've been operationalizing this metabarcoding in bioindicators with our agencies. The method, the way it works basically is that it's called reference condition approach. You have a reference model with your pristine environments, and then you compare this to your test sites, and then based on the biodiversity in those test sites as compared to your reference model, you can have a diagnostic. It's like a health diagnostic for your ecosystem. But of course, taxonomic identification has been a bottleneck for these organisms. These are larvae, very difficult to identify, at the genus or species level. So we partner with a Canadian Aquatic Biomonitoring Network, which is a Canadian program that been tackling this across Canada. And if I can get this to work. Oops. Anyways, but the point is that there have been a lot of sites that they are monitoring, and across Canada, I don't seem to be, this doesn't seem to work, but basically imagine there's a lot of sites across the, especially the border lines, but not enough frequency of sampling, and that's been a bottleneck. So we brought the sequencing-based technology, the metabarcoding, to a pilot study, which we called it Biomonitoring 2.0, and this is still ongoing, and this is linked to the oil-rich province of Alberta, but we did our work in a national park, and started really getting this from sites like this. These are huge wetland-type systems that are very remote, and accessing them, and getting samples from them are really difficult. We standardized an approach based on benthic sampling, soil sampling, water, and also malaise traps for flying insects. And we started generating quite a lot of data. I'm not going to go through all of that. I'm just going to show you some of the trends. These are statistical, multivariate statistical visualization of the data with principal component analysis. And the idea is that, you want to get spatial and temporal separation or sort of resolution of the site. So if you focus on the spatial analysis, we are comparing DNA data at two different levels with the morphology data, and we'll see that with the morphological analysis, there is not enough observations to be able to separate these sites. But when you bring the DNA, you can tease apart the sites and changes. The opposite is with the time. When you look at from 2012 to 2016, with the morphological data, you see a lot of turnover in the community. That's again probably because of limited observations in each year and not a comprehensive look at the biodiversity. But then with the DNA data, we'll see shifts are more not as dramatic in the community. And again, we are now trying to understand the ecosystem using these tools, trying to understand the implications as well. Now, we, just like others, we are thinking about this for masses, for public. And one of the projects that we started, and it's again with WWF Canada coming to us for data, just like Minister Rodriguez was talking today about the Costa Rican government need for having the data. Some of the NGOs, like WWF, they have been doing their own reports, and they need data for that. So they came to us and said, look, for this benthic biomonitoring, we need data, and can you use DNA? And I said, well, how are we going to get the samples? They said, we're going to train public, we're going to train communities. Like this panel here, you'll see the Environment Canada officer training a citizen scientist, from a community in Ottawa with a standardized sampling gear that we provided to bring samples for DNA analysis. That actually was really great, and I spent 8 months of my life writing a grant to try to get the funding for it, which was successful, and we launched the project in October 1st, so we now have a national environmental DNA metabarcoding for freshwater sites across Canada that has started in October 1st. Now, we are doing similar things for terrestrial biosurveillance. This is a project that is led by my colleague, Polly Bear, and we're doing this with malaise traps. So basically gridding the country into different squares, if you will, and link that to ecoregions, and then focusing on high-density sampling with malaise traps, as Dan mentioned. This is going across the province of Toronto. This is 82 sites with 3 million specimens that we just finished, and then linking that to various type of questions, like agricultural landscapes or other types of questions. And again, the data is coming out. We're making sense of this data, and again, I'm not going to go through that. Another big program that is running in South Africa was mentioned is the Kruger National Park Malays program that we are partnering with South African groups to try to use this in various sites at the Kruger National Park. And then very recently, we have also got into the marine setting by actually like bringing in the industrial support. And this is the Newfoundland in the tip of Canadian country and site. This is Newfoundland here, as you can see on the ocean. We were able to take advantage of the oil industry there, and then they invest a lot in R&D. Why not in genomics and biodiversity genomics? So that's what we have been actually mobilizing a center there for these type of applications. And there we bring in ultra-deep sequencing. You know, this is the point I wanted to make, is that genomics is moving rapidly and we need to take advantage of it. And one of the areas is actually like getting the ultra-deep sequencing. This device is like a NovaSeq that can produce 4D human genomes, I think, in one run or so. We're bringing that to the biodiversity genomics. And again, with doing that, we found out that, you know, like again, the green is just what is illuminated through these new devices from the ocean. We're going after rare targets like invasive species, endangered species, and so on. Now, are we ready to depart? This is the picture I took while I was boarding the Egyptian Air. I was ecstatic to see a country mobilizing around biodiversity. Congratulations to Egypt. Like, to getting the Egyptian Air, and I was just boarding in, and everyone is looking at me, why are you taking a picture? This is, are we ready to depart? We are. I mean, with these type of attention to biodiversity from the UN, from the ministers, I think we should bring the tools to empower, you know, like getting to the next stage. And BIOSCAN is trying to do that. We had a workshop that some of you guys were in the workshop in Guelph a month ago, and we talked about possibilities. 27 nations were represented, a pretty nice geographical and also in terms of sectorial and in terms of status, developed nations, developing nations, biodiversity rich nations, like different regions of the world came together to go forward, and I think we are ready to go. And the official launch of the project will be early 2019. The website is live. You can take a look at it. We have an organizational structure. We have mobilized the groups. We have got governing ourselves, prepared to really engage with other groups, and seeking, partnerships, seeking support and criticism, and we would like to work with various groups. I'd like to thank all of these people, the contributors from Center for Biodiversity Genomics in Guelph, but also all of you. I mean, like a lot of the projects that we saw, I was really amazed to see the GTI DNA technology and the work they're doing, and thank you very much for your attention.
Thank you, Meldat. Please remain over here because we have to wrap up, and all those speakers who made a presentation this morning, please come to the front. I would like to ask one single question to every speaker, because we are gathering today on the venue of the Conference of the Parties. Our theme is removing taxonomic impediment for all citizens. Okay, in that context, I would like to invite each one of you to give a last final word for audience. Adriana, would you possibly represent the GTI trainers? Okay. So in the order of presentation, can I invite on behalf of CTAF and GBIF? Is that possible?
I think I can only represent GBIF, actually. So, I mean, I think a critical point to make, and really where we can step up and move forward, is around coordination of all our respective activities. I think we've got better at it. There are fewer silos than there were, but there is still, I think, a long way to go. And I think if we're going to firstly make sure that, for example, all of the national level activity that's going on with an enormous amount of work going into national priorities, species lists, databases, to make sure that that is linked up efficiently with networks happening at the global level, and then also linking together different data types to make sure that there are clear and smooth crosswalks between all of the evidence and data collected in different formats through good collaboration and breaking down of silos. And I know we've all been saying that for a long time. I think there are opportunities, exciting opportunities for us to really move ahead and improve that in the coming period.
I'm supposed to talk on behalf of GTI DNA Tech. I was not one of the trainers, but I helped them a lot, and I was closely involved in all the 10 workshops. I personally participated into 4 of them, so I got to know a lot of the trainers, a lot of the 166 that we trained this year. I have to say I am very proud of what they achieved and of what we all achieved, because all the trainers that ran these 10 workshops, they are all very young. I also have to say that out of 10, 2 were men and 8 were women. We are very proud of them. They did a great job, and just, you know, saying the same thing as GBIF, they managed to work across sectors. So trying to remove the taxonomic impediment, we cannot do this in isolation. And I think we all agree at this table, but this young generation of experts that is being created out there, they managed to break some of those barriers. And if you remember Jamilat's presentation about the intersectoral work, they managed to bring pretty much all the sectors on board, not only governmental agencies and not only academics, but also local communities, NGOs, and private sector. And I think we are ready to depart, maybe, and I think we just need to continue this work.
Thank you. Yeah, I think, in my opinion, is about engagement of the local people and the youth. I think they are very important. So the strategy of starting from top to bottom, it doesn't work. We need to work from bottom to up. We need to engage local people, public, youth, in what we're aiming to do in biodiversity. That's, I think, is very important. Second, we need to think as a scientist. We need to sit down and discuss a lot of issues, how we can use the new technology in the direction to fulfill the CBD requirements. That's we need from us a lot of discussion. The application of all these techniques can help the decision maker a lot, how we can proceed with that. Another message for I'm one of the African countries, we have a problem about information. People would like to keep information in their desks, which is like a disease. We need to think about how we can share our information. Otherwise, we will stuck and there will be a problem. Thank you.
Well, I guess I echo all the other speakers' points. I want to emphasize the how using new technologies like DNA or informatics have enabled us today to democratize taxonomic information and biodiversity information. You know, having you know, the ability to empower everyone to be able to interact with biodiversity is very powerful, but it is disruptive, and we need to rethink a lot of models. You know, I work with a lot of environmental engineering groups, and you know, I know, for example, that their business model is based on number of hours that their you know, their people work on identifying species. You bring a sequencer, and that's disruptive. So we all need to rethink the models that we have with these new technologies. But I tell you, it's happening, and it will happen. And so and I think that it's us as a community to work together to build frameworks around it, but not to, to be a brake for the technology, because it's going to move very quickly. You look at some other technologies, like telecommunication. Telecommunication technologies, the new ones, like the mobile technologies, were not integrated early in North America and places that we had landlines. They were integrated actually in places like here, North Africa, Middle East, and these were where you didn't have the infrastructure. So I think we can learn from this. And in fact, having meetings like this here, it really can be a very good catalyst for getting these technologies, really tested and used. That can be actually an example for us also in North America. So democratization.
Yes, in our case, practically speaking, we can really make non-taxonomists into taxonomists. It's just a matter of looking for that right spot to tickle and let that taxonomy bug bite them and take the natural course in doing taxonomy work if they are really interested into it. And actually, the human being has, it is innate in the human being to classify things naturally. You separate the spoons from the fork, from the knife, you separate your shirts from your pants, you separate your socks from your shoes. And if you could tap that practical, innate character of the human being and simplify it, I can assure you we can make non-taxonomists out of taxonomists, non-taxonomists into taxonomists, and at least para-taxonomists at that level. Thank you.
Thank you very much indeed. And yes, certainly.
Just last point about, I talked with the minister and I sent the paper to the Ministry of Environment, talking about the declaration of COP14 will come by the end of this conference. My question is, who is going to do this own item of this declaration, and how are we going to do that? I think we need to think about these two. Who is going to do that, and how are we going to do that? Standardization of the methods of everything about CBD, restoration of the ecosystem, how are we going to do that? Working with local people, how are we going to do that? And who is going to do that? We need to exchange experience between countries and have training. Then we can move forward in the next 2 years. And that's why I'm working in Egypt. As a scientist, I would like to translate that into that, and then training and moving forward. Thank you very much.
Thank you, Sami. And thank you everyone for participation, and everyone made a very good point. Oh, okay.
I want to ask all my colleagues who have a presentation that I noticed that most of them are very heavy by the new technology of barcoding species. But can we are going in the future to this new technique for taxonomy and they neglect all of historical knowledge about caves from Linnaeus and whatever, or how can we to combine by two methods between two works? Thank you.
So the panel, or does anybody want?
So I think I see the DNA technology a tool in the toolbox, and it may be replaced, later on with some other types of analysis, and I think taxonomy has been, at least the modern taxonomy, for the past 250 years, been using various types of tools. We now have actually like really nice artificial intelligence-based morphological analysis from images, and so on. So I think the idea is how can we use these tools to create knowledge and then transform that. DNA barcoding can be also done on your collections. We have done barcoding on samples that were collected over 200 years ago. So that can effectively link all of the taxonomic knowledge that's generated using, traditional approaches or other approaches to the DNA base. When you get a new specimen, then you can link it to the barcode that you got from your collection. Then you're essentially linking these two types of approaches. So I think it's not really neglect. In fact, I actually think that barcoding has brought quite a lot of funding and attention to doing taxonomy and enabling doing more. So.
Yeah, just to reiterate and endorse that, I think it's very important that the impression isn't given that when we talk about the broader GTI, Global Taxonomy Initiative remit, that it is entirely focused on barcoding. And I think it's perfectly reasonable that with the limited funds and resources available, the particular activities that have been funded and resourced and scheduled within the recent GTI activity has seen barcoding as a useful and a pragmatic thing to concentrate on. But I think particularly going forward, and this is contained, for example, in the statement that we put out, it's very important to give the message that it's all of these different techniques, including the conventional taxonomic sciences, that absolutely need support, and we certainly would not want to be giving the impression, I think none of us, that this is all about one particular technology.
Thank you very much. I think time is up, and we received a lot of good points. And if we wish to mobilize more funding and participation, I believe that it's an economics word. We have very strong asset back. One is vouchered specimens. That remains a very strong asset back of biodiversity. And second is human knowledge. So we have knowledge holders on the podium right now, and we have parties, knowledge users. So we hope that this afternoon we will craft out the best possible messages to the process of development of a post-2020 biodiversity framework. So I would like to say thanks to everyone participated for a long time this morning, and my colleague Fred over there working hard to make sure that our live streaming is up and running, and all those local staff set up the venue and gave us all very the atmosphere with the good hospitality. Thank you very much indeed. So the morning session will close now, and we will resume round table discussion at 2 o'clock. So please come back at 2 o'clock. And on the GTI forum website, there is a commenting document, commenting form uploaded. So anyone who wants to comment on the note by Executive Secretary, everybody is welcome to submit to my email address. So I will wrap up together with the round table this afternoon to consolidate the message from the entire global taxonomy community. So the procedure is okay for everyone? Yes? And then during the lunchtime, everybody do not hesitate to ask questions or suggestions to us, and all those staff members and trainers in this room. One-on-one consultation is available during the lunch period. So we will close now and see you at 2 o'clock in this room. Thank you very much for your participation.